Hello there and welcome to Life Beyond Seen, where curiosity finds a gentle rhythm and the wonders of our world are explored at a pace slow enough to lull the mind but rich enough to spark imagination. Tonight our attention turns not to the ticking of clocks or the pull of stars, but to a place much closer and yet still stranger than almost anything else in the cosmos, the ocean. For all the satellites we have sent into orbit, the probes that whisper back from Mars, the telescopes that stretch vision beyond galaxies, the waters that cover most of our own planet remain largely concealed. And within those waters, countless creatures drift, crawl, hunt, and glow without names, without catalogues, and without recognition. It's a curious situation, isn't it? We inhabit a world where we can stream high-definition video across continents, but we still do not know what most of our neighbours under the sea even look like. If you think about it, that realisation has a strange duality. It's humbling to know that our knowledge is still so partial, that maps remain blank, that even in the 21st century our species cannot claim dominion over all we see. But it's also comforting. There is mystery left. There are still discoveries waiting, not in distant galaxies alone, but in the blue right beside us. Perhaps you felt it yourself while standing at a shoreline, watching the waves roll in. You can see the surface, hear the roar, smell the salt, but everything beyond a few feet of visibility is opaque, hidden. You know life is there, but you don't know what. And perhaps you've wondered, why, after all our technology, after all our ambition, do we still know so little? That's what I'd like to explore with you tonight. Not with hurried lists or quick answers, but with a long, steady wander through the reasons most ocean creatures remain unknown. We'll drift through the vastness of it, the obstacles of darkness and pressure, the tricks of camouflage, the slowness of exploration, and the occasional flash of discovery that reminds us how much more there is. It will be a story of limits, but also of possibility, of how human curiosity collides with the scale and secrecy of the sea. Before we sink too far beneath the waves, I'd love to ask you something simple. Where are you listening from tonight? Perhaps you're near the ocean yourself, maybe within reach of salt air or the cry of gulls. Or maybe you're hundreds of miles inland where the only waves are fields of grass or traffic flowing under streetlights. Wherever you are, have you ever felt the pull of the ocean? That subtle awareness that just beyond the horizon lies a world bigger than we can picture. And when you think of that immensity, does it comfort you or unsettle you? If this kind of journey feels like the right way to end your day, if the thought of sinking slowly into both calm and curiosity helps you rest, I'd be so grateful if you gave this little space a like or a subscribe. It helps others find their way here, and maybe they too need a quiet dive into mystery before they sleep. Think of it less as supporting a channel and more as adding one more lantern to the long pier, guiding new travellers toward calm waters. So let's allow the noise of the day to drift away like foam. Let thoughts quiet into a slower rhythm and begin to step gently into the deep. The question before us is not just about biology or geography, it's about mystery itself. Why do most ocean creatures remain unknown? To answer that, we must first picture the ocean not as we often see it in glossy documentaries or travel ads, but as it truly is in its enormity. Imagine stretching out a globe in your mind. The blue dominates. Over 70% of Earth is water, and of that almost all is ocean, reaching down miles in some places, pressing with a weight the human body cannot withstand. If you tried to swim down unprotected, you wouldn't last long. Not because of monsters, but because the environment itself crushes, freezes, and blinds. We are surface dwellers, peeking into a realm designed for different anatomies, different adaptations. And so, the simplest answer to why ocean life remains unknown is that we cannot reach most of it with ease, but saying it that way feels too simple, too neat. Because every attempt to reach, every submarine, every robot, every camera lowered by cable has revealed not just limitations but surprises. Each glimpse into the deep is like pulling aside a curtain for a second. And behind it is not just one mystery, but an endless cascade of them. The ocean holds not one world, but many stacked on top of each other. Near the surface there's light, warmth, plants that bloom, fish we know from markets and aquariums. Drop a few hundred meters though, and the glow fades into twilight. Colours vanish, red becomes black, and eyes adjust to dim blue. Deeper still, down 1,000 meters or more, there is no sunlight at all, only darkness broken by the rare flicker of bioluminescence, the cold fire of creatures who make their own light. It is in these zones, in these alien landscapes of pressure and silence, that most of the unknown species reside. Not because they are few, but because they are many. Too many for our nets and cameras to collect at once. Too elusive for our crude visits. Too fragile to survive in laboratories at the surface. Consider this. Scientists estimate that we have identified perhaps a quarter of marine species at most. That means the majority are still unnamed, undescribed, unclassified. And many of those might never be, because they live in niches we rarely visit or in forms so delicate they disintegrate when brought up. The ocean is not just vast in distance, it's vast in variety. Microscopic plankton drifting invisibly in the currents may be as alien and important as the giant squid that occasionally reveals itself to deep cameras. Both matter. Both remain, in different ways, unknown. And so, tonight we'll let ourselves sink slowly, exploring the reasons one by one, not with a diver's rush, but with the patience of the tide. The first reason is size. The second is light, or the lack of it. The third is pressure, relentless and crushing. Then come the survival strategies of the creatures themselves, from camouflage to strange life cycles that play tricks on classification. Added to this are our own limitations, the fragility of our tools, the expense of deep expeditions, the slowness of cataloguing. Layered together, they create a picture not of human neglect, but of human humility. We want to know, but the sea asks for patience, and in the asking, the sea keeps its secrets. That's what draws us, perhaps. If every fish had been photographed, if every jellyfish had been named, would the ocean still feel so mysterious? Maybe, but it would not feel quite the same. There is a comfort in knowing that beyond the horizon, beyond the shallow beaches, there are still creatures stranger than fiction, swimming in silence, unbothered by our curiosity, waiting for the rare moment when chance or technology lets us glimpse them. So, let's not hurry. Let's stay with the surface for a while longer, with the thought that most of Earth's unknown life doesn't orbit distant stars but drifts just beneath the waves we take for granted. You may even be closer to it than you realise. A mile offshore, a few hundred feet down, and the world changes completely. And yet, how often do we pause to think of it? That quiet world, living in parallel, invisible, but vast beyond imagination. When we step away from the shoreline and let our imagination sink into the ocean, the first thing to fade is light. It is so easy to forget that the brightness we take for granted on land, the glow of the sun bouncing off pavement or grass, barely penetrates the sea. At the surface it dances, scattering into ripples and sparkles, so inviting that it feels endless. But within a short distance the water swallows it. Even a few dozen meters down, the colours we know shift and disappear. Reds vanish first, then oranges, then yellows, until what remains is only a dim palette of blue and green. Another 100 meters deeper, even those fade into a twilight where the sun is more rumour than presence. Past that there is only darkness, thicker than any night sky, a black so complete it would be overwhelming if not for the faint, startling sparks created by the creatures that live there. It's difficult to picture what this looks like because our minds are used to the idea that night on land still carries a scattering of stars, street lamps, the glow of a phone. Even when the power fails, there is usually something, the pale line of a horizon, the suggestion of a moon. But in the deeper reaches of the sea there is no ambient light at all. Remove the living flashes of bioluminescence, and you're left with nothing but absolute shadow. For us, creatures built on sight, it's an alien state of being. We rely on our eyes so much that we often equate seeing with knowing, and in the ocean's darker layers, vision is limited to those who have adapted strange, sensitive eyes, or given up on sight altogether, relying on vibrations, scent, and sound instead. That's part of why so many ocean creatures remain undiscovered. They live in a world where our own senses fail almost immediately. Divers who descend past recreational depths often describe the disorientation that comes with losing the last trace of sunlight. At first, it's exhilarating. The water cools, the surroundings quiet. Fish appear in shapes and colours that feel exotic but still within the realm of the familiar. Then, as meters turn into tens and hundreds, the realization grows that you're in an environment where nothing is designed for you. The darkness doesn't just hide things, it presses against you, a reminder that down here you are the visitor. For most of human history, that invisible curtain of darkness might as well have been a wall. The best sailors and natural philosophers of past centuries could map coastlines and tides, but what lived below a few fathoms was unknown. Even today, despite cameras, submersibles and remotely operated vehicles, the ocean's deeper zones are still largely unexplored simply because we are working in the dark, literally. It's tempting to compare this to space, and many do. Space exploration captures the imagination precisely because it is distant, cold and unknown. Yet curiously, we often overlook that the deep sea shares those qualities, with one significant difference. Space at least has stars, points of light to guide and inspire. The deep sea has almost none, only creatures that must generate their own light if they want to be seen. Bioluminescence is one of the most widespread adaptations in the ocean. Tiny plankton emits sparks when disturbed, fish lure prey with glowing bait, jellyfish shimmer with eerie blues, and squids pulse with shifting signals. It's beautiful to us, but for them it is a matter of survival, communication, deception. In a place darker than night, to shine is both a risk and an advantage. Sometimes it means drawing in prey, sometimes startling predators, and sometimes signalling to potential mates across the void. To study these creatures, scientists need specialized cameras sensitive enough to detect faint glows without disrupting them. Even then, most of the time, what we glimpse is partial. A flare of light, a shape half hidden, a brief appearance before the animal drifts back into blackness. The idea that we know more about the surface of the moon than the bottom of the ocean has become a cliché, but it persists because it's largely true. The darkness of the deep sea isn't just the absence of light, it is a barrier to exploration. Light is the fastest, most informative sense humans have developed tools for. Our telescopes, microscopes and cameras all depend on it. Remove it, and we are left fumbling. Sonar helps, but sonar provides outlines and echoes, not details. It can map a seafloor ridge but not reveal the shimmer of scales or the delicate structure of a jellyfish. We lower instruments with lights, but lights attract or scare animals, distorting what we're trying to study. It is a puzzle. The very act of trying to observe can change what is being observed. Imagine lowering a submersible into the deep. Its lights cut cones through the blackness, illuminating particles that drift like snow. The beam reveals a fish for a second, strange, angular, with teeth that glint in the glow before it slips away. Was it rare? Common? We don't know. We only know it was there, briefly, and then gone. Multiply that moment across thousands of dives, and you start to see why so many species remain unnamed. It's not that they don't exist in abundance, but that they prefer a home where our reach is clumsy and our gaze is narrow. Even in shallower zones, twilight plays tricks. Many animals are masters of blending in, changing colour to match the faint light filtering down. A red fish, invisible in the blue darkness, is effectively cloaked. Transparent bodies mean even less can be detected by sight. In these environments, The very strategies that keep creatures safe from predators also keep them safe from our curiosity. We can drag nets, but nets tear fragile organisms apart. We can set traps, but traps favour stronger, more mobile species. So much slips through simply because we're using tools built for a world of light, in a world where light doesn't exist. Think for a moment about how much of human activity depends on vision. From reading to driving to cooking, sight dominates. And yet, in the majority of Earth's biosphere, the oceans below sunlight, sight is nearly useless. That alone should remind us how limited our perspective is. We look into water and expect to understand it as we understand land, but down there the rules are different. Animals evolve not for what pleases our eyes, but for what works in shadow. Some have eyes as large as dinner plates to catch the faintest trace of light. Others have no eyes at all, relying on sensitive hairs that detect currents or organs that sense chemical trails. The adaptations are endless, each tailored to darkness, each alien to us, and each a reason why our understanding lags behind. Consider how long it took even to capture clear footage of a giant squid. For centuries it was legend, whispered about by sailors who claimed to see enormous arms rising from the water. Carcasses occasionally washed ashore, but living proof remained elusive. Why? Because the squid lived in the dark. Every attempt to observe it with bright submersible lights sent it fleeing. Only when researchers devised a low-light camera with a subtle bioluminescent lure did they succeed. And when they did, the squid appeared not as a monster but as an elegant predator, red and graceful, gliding silently through the black. That breakthrough reminds us, it isn't that these animals aren't there, it's that they are there in conditions we are not adapted to handle. Another way to think of the deep sea is as layers of inaccessibility. The first barrier is depth itself, the sheer distance to travel. The second is pressure, which we'll dwell on more later. But the third ever-present barrier is the dark. It shapes everything. It decides which animals thrive and which vanish. It makes every observation difficult, and it is part of why the majority of species that live in these zones remain outside our books and databases. It's humbling to imagine how much life exists in that black expanse. We know of deep-sea vents with communities that flourish without sunlight at all, feeding instead on chemical energy from the Earth's crust. We know of mid-water regions filled with gelatinous creatures, delicate as lace, glowing faintly as they drift. We know of predators with teeth like needles and prey with bodies that collapse if brought up. And yet, for each known example, there are surely dozens, maybe hundreds, that we've never even glimpsed. The absence of light is both their shield and their obscurity. For us on land, night is temporary. Morning always comes. In the ocean, night is permanent. It isn't a cycle, it's a condition. Imagine being born, living and dying in an environment where sunlight never existed. That's the reality for many ocean creatures. To us that sounds extreme, even hostile. But for them, it is simply normal, the stage on which all their survival strategies play out. It's only our land-based perspective that calls it strange. For them, it is home. So when we ask why so many creatures remain unknown, the darkness is always part of the answer. We can't study what we can't see, and we can't see without light. And light doesn't reach far enough. Our machines try to compensate, but they are crude substitutes compared to the evolutionary brilliance of animals that have been navigating this blackness for millions of years. That mismatch keeps us guessing, keeps us piecing together fragments, keeps us humbled, and it sets the stage for the next truth about the ocean's secrecy, which is that darkness is not the only obstacle. Just as important is the crushing weight of the water itself, the pressure that grows with every meter. If darkness blinds us, pressure locks the door, reminding us that this is a world not built for air-breathing creatures like us. For as long as people have looked up at the night sky, space has carried the reputation of being the greatest mystery. The stars are countless, the distance is unimaginable, and the possibilities endless. It seems natural to call it the final frontier. Yet if we pause for a moment and look in the opposite direction, not above us but beneath us, the irony becomes clear. We know far more about what's overhead than what's underfoot. We've mapped the surface of Mars in exquisite detail, traced the winds of Jupiter, and measured the chemistry of planets so far away that light from them takes years to reach us. Meanwhile, the seafloor of our own world is still more charted by guesswork than direct measurement, and the animals that inhabit it remain largely invisible to us. The ocean, in many practical ways, is still more mysterious than space. That claim sometimes surprises people. After all, space is infinite. The ocean at least has boundaries. You can measure its depth, define its volume, outline its edges on a globe. But mystery is not measured by size alone. Mystery is measured by access. And when you compare the practical access we've gained to outer space with what we've gained to the deep sea, the contrast becomes sharp. Humans have placed astronauts on the moon, orbiting stations in space, robotic rovers on Mars, telescopes that look beyond galaxies. These achievements are celebrated as they should be, but the number of people who have physically descended into the deepest parts of the ocean can be counted on one hand. The number of sustained expeditions into the Hadal trenches, those deepest grooves of the sea floor, is tiny compared to the dozens of missions to orbit. Even in an era where billionaires launch themselves into suborbital space for leisure, deep ocean exploration remains rare, risky, and poorly funded. One reason for this imbalance is perception. Space has captured imagination for centuries in a way the ocean has not. The stars are visible every night. They invite speculation. Myths and constellations were woven around them long before science existed. They symbolize destiny, wonder, possibility. The ocean, by contrast, is near yet opaque. You can see the surface, but not what lies beyond. It inspires awe, yes, but also fear. Sailors told tales of monsters, whirlpools, endless abysses. Even as navigation improved, much of the ocean remained treated as dangerous unknown, better crossed than studied. Space promised inspiration, the ocean threatened disappearance. That cultural bias lingers. Space agencies receive massive budgets, while oceanographic institutes scrape by with fractions in comparison. Another reason is technical. Getting into orbit requires speed and energy, but once you're there, the environment is stable. It's a vacuum, but it's predictable. Instruments function in the absence of air, and temperature extremes can be engineered around. The ocean, however, is not predictable. Pressure increases relentlessly with depth, crushing anything not designed to withstand it. Salt corrodes metal. Darkness renders cameras nearly useless without disruptive lights. Currents can drag instruments away, and unlike space, you can't simply hover indefinitely. Submersibles must return before supplies run out. Every descent is limited. Every attempt is costly. In many ways, reaching the bottom of the sea is harder than reaching orbit, not in terms of energy, but in terms of durability and endurance. Consider the statistics. Roughly 80% of the ocean floor is still unmapped in high resolution. Compare that with Mars, which we've mapped nearly completely from orbit. We have more accurate topographic data for Venus, shrouded in toxic atmosphere, than for many parts of Earth's sea floor. Why? Because radar can penetrate Venus's clouds, but mapping the ocean floor requires sonar from ships that must travel slowly, methodically, across vast distances. It is simply not practical to cover it all at once. At the current pace, complete high-resolution mapping of the seafloor may still take decades. Until then, vast regions of our own planet remain more hypothetical than real, and then there is life. When we look to space, we search for life as a possibility, a maybe. On Mars, we hunt for fossils of microbes. On icy moons, we speculate about oceans beneath crusts of ice. In distant star systems, we analyze atmospheres for chemical traces that might hint at biology. But in the ocean, life is not hypothetical. It is abundant, diverse, and constantly surprising. The mystery here is not whether life exists, but what forms it takes, and those forms often outpace our imagination. Fish with transparent heads, worms that feast on bones, shrimp that thrive in near-boiling vent fluids, jellies that glow like neon lanterns. These are not guesses, they are realities. And if such strange life exists in the small slice we've managed to glimpse, how much stranger must be the life we haven't seen? It's worth noting that every significant deep ocean expedition in recent decades has uncovered new species, not just once in a while, but routinely. Drop a submersible into a little studied trench, and the odds are high that you'll return with images of creatures no one has ever documented before. Some are small, some large, some elegant, some grotesque, but all are new. This regularity of discovery means one thing. The unknown is not at the fringes, it is the norm. The ocean remains a mystery because discovery is the baseline, not the exception. Contrast that with space exploration. The last time we encountered a truly new type of celestial body was in the detection of exoplanets and interstellar objects. Those discoveries were thrilling, but they are few and far between. In the ocean, newness happens every dive, every net haul, every camera drop. The difference becomes sharper when you think of proximity. Space is far, but our telescopes extend our reach. We can see galaxies billions of light years away with clarity. The ocean is near, but our instruments falter just beyond the surface. Imagine standing on a beach. Beneath your feet, only a kilometre away horizontally, and maybe a few hundred metres vertically, there could be an animal unknown to science. Right there, within a casual swim's distance, is mystery as profound as any distant exoplanet. But we can't see it. It hides in black water, behind pressure, in silence. That juxtaposition is one of the reasons the ocean feels more mysterious than space. It is mystery concealed by proximity, hidden in plain sight. There is also the matter of fragility. Space is vast and empty. You can point a telescope at the sky, night after night, and the stars will still be there. But ocean creatures are delicate. Many cannot survive handling or removal from their pressure and temperature ranges. Collect them with nets, and they arrive on deck mangled or collapsed. Even if intact, exposure to surface conditions can kill them within moments. As a result, much of what lives in the sea has only been seen fleetingly, sometimes as ghostly blurs on video or as fragments in a sample jar. That fragility means the mystery is deeper than just mapping. It's about the very existence of organisms we may never be able to properly observe alive. Another factor is the sheer scale of biomass. In the deep ocean, there are billions of individuals moving constantly. Tiny plankton rise and fall in what's called the Deal vertical migration, the largest daily movement of biomass on Earth. Predators follow them. Entire ecosystems shift position with the rhythm of day and night. In space, the stars are fixed. Planets orbit predictably. In the ocean, everything is in motion, complicating study. Mystery thrives in motion. Trying to study it is like trying to understand a forest while being allowed to glimpse only one tree at a time, and even that tree refuses to stay still. There's also the human element of priorities. We have chosen, collectively, to place more emphasis on space than on the ocean. Budgets reflect that. Public interest reflects that. Children grow up dreaming of astronauts, not aquanauts. We have movies, novels, and cultural icons that celebrate the exploration of the stars. Comparatively little celebrates the exploration of the depths, beyond occasional stories of giant squids or deep-sea horrors. That imbalance in storytelling feeds into funding, which feeds into exploration, which feeds back into storytelling again. As a result, the ocean's mysteries accumulate while space's mysteries are gradually chipped away. Still, despite these differences, both frontiers share a certain allure. Both remind us of limits. Both humble us. But the ocean's mystery carries a special weight precisely because it is here. It is part of the very system that sustains us. The currents regulate climate. The plankton create oxygen. The fisheries feed billions. And yet, the vast majority of species within those systems remain unnamed. In that sense, the mystery of the ocean is not just an academic puzzle. It is a direct gap in our understanding of the planet that keeps us alive. Space may hold distant answers to cosmic questions, but the ocean holds immediate answers to ecological ones. That urgency makes the mystery sharper, more pressing. It's fascinating to think that in the popular imagination, alien life is envisioned as strange, glowing, often tentacled, yet many of those traits already exist in the ocean. If a visitor from another planet wanted to meet bizarre, unearthly life, they wouldn't need to go beyond Earth. They would only need to lower a camera into the deep. In that sense, the ocean is our own alien world, hidden beneath a thin layer of waves. We search for life on other planets with enormous effort, but overlook the fact that right here, within reach, we have only scratched the surface of the bizarre and the beautiful. Perhaps the greatest irony of all is that space may someday feel less mysterious than the ocean. With telescopes like the James Webb, with upcoming missions to icy moons, with advanced sensors and spectrographs, our knowledge of distant objects accelerates. But the ocean remains stubborn. It doesn't yield easily to remote sensing. It doesn't display its treasures in light. It demands presence, descent, immersion. And because those are hard, the pace of revelation is slow. A new exoplanet can be discovered by algorithm in a matter of days. A new fish may take years of planning, a dangerous dive and luck. Mystery here is slow, layered, patient, and that patience shapes our understanding of what it means to explore. Outer space may feel romantic, but the ocean reminds us that mystery is not always glamorous. Sometimes it is cold, dark, crushing, silent. Sometimes it resists attention. Sometimes it only allows glimpses. That kind of mystery demands humility. And perhaps that humility is the real reason the ocean feels more mysterious than space. Because every time we try to know it, it reminds us that knowing is partial, that seeing is fleeting, that we are guests, not owners. The more we learn about the ocean, the more it resists being fully known. And yet, it keeps drawing us back. With every expedition, every sonar sweep, every bioluminescent flash caught on film, we are reminded that right here on Earth lies a world as strange, as vast, and as unknown as any galaxy. And so, as we continue drifting through this exploration of why so many creatures remain unseen, the contrast between space and sea prepares us for the next barrier. Because if light fails us, and if human priorities lean elsewhere, then the very scale of the ocean itself ensures that the unknown persists. Size and distance become obstacles of their own, turning every attempt at comprehension into just a tiny sketch on a canvas too large to finish. When people think about mystery, they often imagine something hidden behind a veil, a secret that could be revealed if only the curtain were pulled aside. With the ocean, the curtain is not a veil, but a horizon that never ends. The vastness itself is the problem. Even if the sea were clear and shallow, simply covering so much of the planet would make it a challenge to know fully. But add depth upon depth, currents that shift constantly, and ecosystems layered like a stack of invisible worlds, and the challenge becomes almost insurmountable. So much sea, so little seen. It helps to remember the scale. More than 70% of Earth is ocean. That's not just a large fraction. It means that most of the planet's surface is water. Land, the part we build cities on, the part we farm and walk and map in intricate detail, is the minority. If you shrank Earth down to the size of a globe in your hand, you would see that blue dominates. Continents are like islands in a larger sea. We are land dwellers, but we are not planet dwellers. Not really. Earth, from a cosmic perspective, is an ocean planet with scattered fragments of land. And it isn't only about area, it's about depth. The average depth of the ocean is more than 3 kilometres. The deepest trenches go down nearly 11. To put that into perspective, if you took Mount Everest, the tallest mountain above sea level, and set it in the Mariana Trench, its peak would still be more than 2 kilometres underwater. We think of mountains as monumental, but in comparison to the ocean's depth, even the tallest peak is small. That depth represents an immense volume of habitat, far greater than all land combined. Most of Earth's habitable space for life is underwater, not on the surface where we live. With such scale, it becomes obvious why so many creatures remain unknown. To survey the ocean systematically would take thousands of lifetimes, even with the best equipment. Ships move slowly. Submersibles descend cautiously. Satellites can only infer from above, not reveal. Each expedition covers a tiny patch of territory, and even then only temporarily. Imagine trying to document every insect in the Amazon rainforest by walking one trail for a single afternoon. That's the scale problem. Only magnify it by millions because the ocean is larger than every rainforest combined, and more three-dimensional too. This vastness isn't empty. On the contrary, it is alive with staggering abundance. Tiny organisms float in the upper layers, feeding fish, which in turn feed larger predators, which in turn sustain entire chains of existence. Schools of fish migrate across thousands of kilometres. Whales traverse basins from pole to tropics. Jellies drift in numbers so high they sometimes clog nets and machinery. The ocean is not still, it is in motion at every level, from plankton pulses to gyres that circle entire basins. Trying to catalogue life in such constant flux is like trying to take attendance at a stadium where everyone is always moving, entering, leaving and shifting seats at once. The vastness ensures that by the time you've observed one corner, another has already changed. Scientists sometimes estimate that millions of species may live in the ocean, most of them still unknown. The exact number is impossible to pin down, but even conservative guesses suggest we have named only a fraction. The rest are hidden not because they are rare, but because they are spread across an arena too wide to cover. Many of them are small, blending into background waters, and only show themselves under specific conditions. Others live in remote habitats far from human presence. Every voyage that sets out with the goal of discovery comes back with something new. And that should tell us something important. The unknown isn't an exception waiting at the edges of knowledge. The unknown is the rule. Think of the difficulty of mapping even a single seamount, one of the countless undersea mountains that rise from the floor but don't break the surface. Many seamounts have never been visited directly, even though they can host ecosystems as diverse as coral reefs. Some of them teem with fish that gather to spawn. Others serve as oases for predators. Others are covered in strange corals and sponges that grow slowly in the cold dark. Each seamount could hold dozens of species never seen before, but with hundreds of thousands of them scattered across ocean basins, the vastness ensures that most remain completely unstudied. It is also important to realise how little of the ocean is regularly monitored. Shipping lanes, fishing grounds, coastal regions near ports. These are areas we know best because human activity forces us to. But the central basins, the remote southern seas, the under-ice waters of the Arctic and Antarctic, these areas are rarely visited. Months or years can pass without any ship traversing them with scientific intent. In those intervals, entire events could occur unnoticed. Migrations, blooms of plankton, mass gatherings of squid, even the rise and fall of species populations. On land, such changes are harder to miss. Cameras and satellites track forests and deserts. But in the ocean, vast changes may happen with little record, simply because the scale makes constant surveillance impossible. Even the sea floor, which might seem fixed, is vast and variable. It holds canyons larger than the Grand Canyon, ridges that circle the planet like seams, volcanic vents that release chemical plumes into the water. Each geological feature becomes a habitat, hosting life uniquely adapted to it. Hydrothermal vents, for instance, support entire communities, powered not by sunlight but by chemical energy. Before the late 20th century, scientists didn't even believe such ecosystems could exist. Now we know they are abundant, scattered along ridges in every ocean basin. And if such massive ecosystems went unnoticed until recently, how many smaller ones still lie unseen? This vastness also resists quick classification. On land, we can map biomes: rainforest, desert, tundra. They are discrete and visible. In the ocean, biomes blend vertically and horizontally. Light fades gradually with depth. Temperature shifts with currents. Nutrients rise and fall with upwelling. Habitats overlap in layers that are not easy to draw boundaries around. As a result, a creature might migrate through several biomes in a single day, living in multiple contexts at once. That mobility makes it harder to categorize and harder to study. In such a vast fluid system, mystery is built in. When we consider why the ocean is more mysterious than space, vastness is at the center. Space is endless, yes, but we can look at it all at once. Point a telescope at the sky, and you're seeing across unimaginable distances simultaneously. The ocean cannot be seen at once. Its scale is multiplied by opacity. You can't look across it. You can only enter it piece by piece. That piecemeal access is what makes it feel infinite in practical terms. Each dive or expedition feels less like exploration of the whole and more like exploration of a tiny drop. The vastness also shapes human psychology. We like to believe that frontiers can be conquered, that with enough effort we can make maps complete. With the ocean, progress always feels partial. Each discovery expands the map slightly, but also expands awareness of how much is left blank. The more we learn, the more we realise how little we know. It's a humbling paradox. Vastness breeds not closure, but endless curiosity. For example, even fisheries science, which focuses on commercially important species, is limited by scale. We track tuna, cod, salmon, shrimp, species tied to economies, but alongside them swim countless others never measured, never counted. We focus on the few because we cannot track them all, and so our picture of ocean life is skewed, shaped by what we can see and what we care about economically, not by the true diversity beneath the surface. The rest remains in shadow, not because it is unimportant, but because the ocean is too vast for us to see beyond the most immediate priorities. To confront vastness, we use technology: satellites that estimate ocean colour, sonar that maps depth, autonomous vehicles that glide for months. These tools are remarkable, and they have expanded our reach enormously. Yet they still cover only fractions. Even the most ambitious mapping programs crawl slowly compared to the enormity of the sea. The ocean is always larger than our instruments, always one step beyond. This vastness is not a passive backdrop. It shapes the creatures themselves. Wide ranges mean populations can spread thinly, making encounters rare. Remote habitats isolate species, leading to unique adaptations. Some organisms may live their entire lives without ever encountering a human presence, not once in centuries. For them, mystery is not a condition, but a normal state. The vastness gives them privacy. It shields them from us simply by being too large to cross completely. And so, when we ask why so many ocean creatures remain unknown, the answer lies partly in the sheer expanse of their home. Too much water, too many depths, too wide a canvas for us to fill. Every expedition is a dot in an ocean of blankness. Every map is a sketch on a canvas that stretches beyond reach. The vastness ensures that the unknown will not disappear soon. Even with faster ships, better submersibles and more funding, the scale problem guarantees that mysteries will always remain. Which is not discouraging if you think about it another way. The vastness is why the ocean can continue to surprise us indefinitely. It is why mystery will not vanish after one generation of explorers. It ensures that discovery is renewable, that newness is guaranteed, that future scientists will have as much wonder to chase as those before them. It means the unknown is not a temporary condition, but a permanent feature, and it prepares us to consider the next obstacle beyond size alone, the fading of light. For even in the parts of the ocean we can reach, visibility shrinks quickly, and with it, our ability to see the creatures who live there. The farther you descend into the sea, the quicker you realise how much of life depends on light. At the surface, sunlight glitters and scatters. The top few metres shimmer with colours, each wave flashing like liquid glass. But very soon, the glow thins. Every additional metre you go down, sunlight weakens, red vanishes, orange dissolves, yellow dulls, green hangs on a little longer, until eventually the world turns into a dim blue haze. Past 200 metres, the ocean slips into twilight, and below 1,000 the light disappears entirely. What remains is not just darkness, but a darkness denser and more complete than most people ever experience. Without artificial illumination, it is an eternal midnight. This is not just an aesthetic change. The fading of light dictates everything about life below. Plants cannot grow without photosynthesis. The ocean's lush gardens of plankton and algae only bloom where the sun can reach them. Beneath that boundary, life must rely on other strategies, feeding on detritus falling from above, hunting fellow animals, or thriving on chemical energy from vents and seeps. That division between light and no light shapes the entire structure of ocean ecosystems. Above, photosynthesis drives food webs. Below, survival becomes improvisation. Each fading photon strips away not only colour but opportunity, forcing adaptations that are as strange as they are ingenious. For humans, light is more than energy. It is the sense we trust most. We are visual creatures, accustomed to navigating a world by what we see. When light fades, our certainty fades with it. And that is exactly what makes the ocean so difficult to know. In shallow waters we can snorkel or dive and see fish darting in schools, corals spreading in patterns, turtles swimming by. But once sunlight no longer penetrates, our presence becomes clumsy. We must carry light with us, and light changes everything. Some animals flee it, others are drawn toward it in ways that make them vulnerable. Still others ignore it entirely because their existence has never relied on vision. That bias, our dependence on light, means we will always distort what we try to observe. Think of how much discovery in human history has depended on simply seeing something for the first time. A naturalist collects a plant, draws it, labels it. An astronomer points a telescope and spots a new moon orbiting Jupiter. Seeing and knowing have always been intertwined. In the ocean, light fades too quickly for that simple method to work. You cannot just look and catalogue. Darkness makes creatures invisible until they choose to reveal themselves. And often, what reveals them is not reflected sunlight, but light of their own making. Bioluminescence is one of the most remarkable consequences of a dark ocean. When creatures cannot rely on the sun, many evolve to generate light themselves. Some use specialised organs filled with chemicals that react to produce a glow. Others host symbiotic bacteria that shine on their behalf. The reasons vary. Some use light to lure prey, dangling a luminous lure like a glowing fishing rod. Others use it to confuse predators, flashing suddenly to startle or escape. Some release glowing clouds into the water the way a squid releases ink, a smoke screen of sparkles that buys them time to flee. Still others use light to signal mates, a coded language invisible to all but their own kind. For us, encountering bioluminescence feels like magic. Divers describe drifting in pitch-black water, then moving their hands and watching sparks flare like underwater stars. Sailors in past centuries saw glowing wakes, trailing behind their ships and imagined supernatural forces. But the truth is even more extraordinary. Bioluminescence is not rare. It is common, perhaps even dominant, in the dark layers of the ocean. Some scientists estimate that the majority of midwater creatures are bioluminescent in some way, which means that in the lightless deep, life has not vanished. It has simply switched strategies, turning darkness into a stage for countless glowing performances. Yet those performances often escape us. Because bioluminescent flashes are faint, they are difficult to record without sensitive cameras. Many last only a fraction of a second, vanishing before instruments can capture them, and the creatures themselves are elusive, often small, fragile and quick to retreat. So even though entire ecosystems might be alive with glimmers at any moment, what we observe directly is minimal. Each glimpse feels like an accident, a gift, and that rarity keeps most of the cast of this glowing world unknown. Light fading also transforms how animals appear when we do catch sight of them. Many deep-sea creatures are red, orange or black, colours that are effectively invisible in the blue twilight. To us, under artificial lights, they might look vivid, but in their natural setting they're cloaked. Others are transparent, their bodies so delicate that only faint outlines distinguish them from the surrounding water. Still others have mirrored sides, reflecting whatever dim light passes by, making them vanish into background darkness. These adaptations make sense in a world where light is scarce, but they also mean that human eyes, trained to look for contrast, often miss them entirely. A fish that glows brightly under a submersible spotlight might normally be nearly invisible. The truth of its life is hidden by the absence of natural light, multiplied by our intrusion with artificial beams. This is one of the key reasons so many creatures remain undiscovered. In darkness, invisibility is easier to achieve than presence. Camouflage, transparency and stillness mean that even if we drop a camera, it may pass within inches of an animal without ever detecting it. Imagine trying to count birds in a forest at night with only a flashlight. You would see a few, but most would remain unseen, hidden by shadows and silence. That is how we study the ocean, an incomplete picture by necessity. The absence of light also warps our sense of scale. We imagine the ocean as empty simply because we can't see the life it holds. But darkness doesn't mean lifelessness. In fact, the mid-water zone, sometimes called the twilight zone, is believed to hold some of the largest biomass on Earth. Billions upon billions of small fish, mostly lanternfish, migrate up and down every day in search of food, moving hundreds of meters vertically in one of the greatest migrations on the planet. Yet because it happens in darkness, out of sight, it remained unknown to science until relatively recently, and even now we can only estimate its scale. Nets bring up samples, sonar detects layers of density, but the true abundance remains concealed by night. When light fades, our tools must compensate. Sonar sends sound waves and measures echoes, revealing shapes and schools. But sonar cannot show detail. It can tell us that something is there, not what it is or how it looks. Cameras need artificial lights, which, as we've said, alter behaviour. Collecting specimens often damages fragile organisms. In short, every method has limitations magnified by the darkness. And so, most creatures remain mysteries, glimpsed briefly, recorded incompletely, left undescribed. There's also the psychological effect of darkness. For humans, darkness is unsettling. We associate it with danger, uncertainty, vulnerability. In the deep sea, those associations become amplified. The blackness is absolute, stretching for kilometers. You can float in a submersible and see nothing beyond the glow of your own lights, nothing to anchor your vision. That emptiness triggers imagination. Sailors once filled it with sea monsters. Today, even scientists admit to feeling awe and unease when faced with it. In such conditions, discovery feels both thrilling and improbable. The mind knows that life is out there, but the eyes report only emptiness. And that tension between knowledge and vision fuels the mystery. Interestingly, light fading doesn't only affect our ability to see, it affects the creatures themselves in ways that complicate study. Many deep-sea species are adapted to detect faint light far better than we can. Their eyes are enormous relative to their bodies. Some have tubular eyes pointing upward, designed to catch the silhouettes of prey against the faint glow from above. Others have multiple sets of eyes specialized for different directions. Some have visual pigments tuned to the precise wavelengths of bioluminescence. In other words, they live in a world of signals invisible to us. Their reality is not our reality. We cannot see what they see, and that means even when we observe them, we understand only fragments of their experience. This gap is one of the reasons mystery multiplies. Light doesn't just allow us to see, it structures perception. When light fades, creatures evolve new ways to interact, communicate, and survive, ways we are barely capable of imagining. And because we can't share that sensory world, we remain outsiders looking through a keyhole. We can record flashes, but we don't know their full meaning. We can measure adaptations, but we don't feel their lived effect. And so, much of deep-sea life remains not only unknown but perhaps unknowable in its full context. If you think about it, light fading is both literal and symbolic. Literally, it prevents us from seeing. Symbolically, it represents the point at which our methods falter. We are so accustomed to light-guiding knowledge that when it disappears, mystery multiplies. Each photon lost multiplies uncertainty. Each layer of darkness multiplies hidden forms. In that sense, the absence of light is not just a condition of the ocean. It is the engine of its secrecy. And this secrecy prepares us for the next challenge. Because once light is gone, another barrier asserts itself with even more force. Pressure, invisible and relentless, begins to shape not only the bodies of creatures, but the limits of our machines. Darkness hides, but pressure crushes. Together, they ensure that most of the ocean's inhabitants will remain out of reach, glimpsed only occasionally, recorded incompletely, left in the long catalogue of the unknown. The deeper we sink, the more the ocean transforms into something that feels less like part of our world and more like a realm with its own laws. The abyss, stretching from about 4,000 meters down to the seafloor itself, is not just dark. It is hostile in ways difficult to imagine. Pressure rises to levels that would crush submarines not built with the strongest materials. Temperatures hover just above freezing. Sunlight has long since vanished. It is an environment that feels reluctant to reveal its inhabitants, reluctant to let us trespass, reluctant to share anything more than fragments. And yet, every once in a while, the abyss does allow glimpses, and those glimpses remind us of just how much remains hidden. The sheer physical force of pressure is the most immediate obstacle. Every 10 meters you descend adds another atmosphere of pressure. At 4,000 meters, the weight of the water is 400 times what we experience at the surface. To compare, it's like balancing several large cars on every square inch of your body. No human could withstand it directly. Even the submersibles designed to reach those depths are marvels of engineering, with hulls that must resist crushing without buckling. Historically, few vessels have ever reached these depths, and fewer still have returned intact. That scarcity of visits explains much of why the abyss remains so little known. Pressure doesn't only affect machines, it shapes the biology of every creature that calls the abyss home. Cell membranes must be structured differently to remain flexible under crushing weight. Proteins inside bodies must resist denaturation that would occur under surface conditions. Many deep-sea fish collapse into gelatinous puddles if brought up too quickly, because their tissues are built to function only under extreme compression. For them, the surface is lethal, just as the abyss is lethal for us. This mutual incompatibility means study is difficult. We can't easily bring them to us, and we can't easily join them. The abyss enforces distance, ensuring that most of its creatures remain unseen. And yet, life finds ways to exist there in astonishing forms. When submersibles do descend, they encounter animals adapted to extremes that defy our assumptions about habitability. Sea cucumbers crawl slowly across sediments, that stretch endlessly into darkness. Strange fish with enormous mouths wait motionless for prey, conserving energy in an environment where food is scarce. Crustaceans scavenge tirelessly, feasting on anything that drifts down from the layers above. Even in what looks like a desert of mud and cold, communities survive, proving that life can persist under conditions that seem impossible. What makes the abyss reluctant to reveal its inhabitants is not only physical hostility but also scarcity. Food is limited because no sunlight fuels primary production at these depths. Instead, organic material must drift downward from above. A constant but thin rain of dead plankton, fecal pellets, and the occasional sinking carcass of a larger animal. Scientists call it marine snow, a gentle drizzle of nourishment that keeps the abyss alive. Most of it is consumed before it ever reaches the seafloor, so what remains is sparse. Animals here live slowly, conserving energy, growing at reduced rates, reproducing infrequently. That slowness means encounters are rare. You could traverse kilometers of seafloor and see only a handful of visible animals. The abyss hides its richness by spacing it thinly across a canvas too wide for us to survey quickly. Still, the reluctance is not absolute. When our cameras settle onto the bottom, when our lights sweep across the sediment, creatures often appear that surprise us. Dumbo octopuses with ear-like fins drift with gentle grace. Ghostly fish with transparent skin reveal organs beating faintly inside. Giant amphipods, shrimp-like creatures scuttle across the floor in numbers we did not expect. Each reveal is quiet, understated, almost accidental. The abyss does not parade its residents before us. It allows us only fleeting encounters, reminders rather than full introductions. Occasionally, though, the abyss offers something dramatic. When a whale dies and its massive body sinks, it creates what scientists call a whale fall. That sudden bounty transforms a patch of seafloor into a frenzy of activity. Hagfish wriggle inside the carcass, stripping flesh. Crabs and amphipods swarm to feed. Over time, bacteria colonize the bones, producing chemicals that attract specialized species found nowhere else. Entire ecosystems arise from a single body, persisting for decades as the bones are gradually consumed. Before scientists discovered whale falls, no one imagined such oases existed in the abyss. Their reluctant reveal changed our understanding of deep-sea ecology, reminding us that the abyss holds surprises not in spite of its emptiness but because of it. Hydrothermal vents are another of those reluctant revelations. Found in the late 1970s along mid-ocean ridges, they shocked scientists by hosting communities independent of sunlight. Instead of photosynthesis, these ecosystems rely on chemosynthesis, bacteria that use chemicals from vent fluids to produce energy. Around them thrive giant tube worms, clams, crabs, and fish. The discovery redefined the boundaries of habitability, showing that life could flourish in darkness, nourished by Earth's inner chemistry. It also raised the possibility that similar life could exist on other worlds, such as the oceans beneath the icy shells of Europa or Enceladus. The abyss, by reluctantly revealing vents, expanded not only our view of Earth, but of the cosmos. But the abyss remains secretive. Vents are scattered, often miles apart, and difficult to locate. Whale falls are unpredictable. Encounters with larger predators like giant squid or deep-diving sharks are rare. Each glimpse feels more like a negotiation than a discovery, as though the abyss grants permission sparingly. That reluctance is not mystical. It is simply the product of conditions, depth, pressure, darkness, scarcity that make life elusive. Yet it feels personal to us because we so desperately want to know, and the ocean so consistently withholds. Technology helps, but only in increments. Remotely operated vehicles and autonomous subs allow us to linger longer, to explore without risking human lives. Cameras improve, sonar maps in finer detail. Still, the abyss resists. Machines can travel there, But not easily, not cheaply, not often. The abyss remains vast and rarely visited. Every descent is still an event, not a routine. That scarcity of effort matches the scarcity of life, compounding the reluctance. Most of the time, most of the abyss is simply unobserved, and in that absence, mystery multiplies. It's worth remembering how recent even our limited knowledge of the abyss is. For centuries, people assumed the deep sea was barren, a lifeless void. The idea of an azoic zone prevailed, that below a certain depth nothing could survive. Only in the late 19th century, when dredgers pulled up living animals from depths once thought sterile, did that assumption collapse. Even then, the abyss revealed itself only reluctantly, one net haul at a time. Only in the last few decades have we begun to see its living communities directly. The abyss has always been there, but our awareness of it is still in its infancy. And because of that, we can be certain the reluctance is far from over. For every Dumbo octopus we film, there are surely many species of equal strangeness still beyond our reach. For every whale fall we stumble upon, countless others have already decayed unseen. For every hydrothermal vent community studied, dozens more pulse quietly in the dark. The abyss does not reveal itself all at once. It offers its secrets slowly, almost grudgingly, forcing us to approach with patience. That patience is humbling, but it also enriches discovery. Because when something finally is revealed, the impact is profound. The first clear images of a giant squid in its natural habitat made headlines worldwide, not because one animal matters more than others, but because it symbolized the abyss finally yielding a secret long withheld. Each reluctant reveal carries that weight, the sense that the ocean has given us permission to glimpse what it usually hides. And as we move forward in this journey through why so many creatures remain unknown, the abyss reminds us that reluctance itself is a kind of barrier, not a conscious one, but a practical one. Environments like this cannot be fully surveyed quickly. They will never give up all their mysteries at once, which means that just as the fading of light multiplies secrets, the presence of crushing pressure and scarcity ensures that the deeper we go, the more reluctant the reveals become, and in that reluctance, mystery is preserved. But even in reluctance, there is beauty. Each faint encounter is enough to remind us that life is resourceful, adaptable, and persistent beyond our imagination. And those reminders prepare us to understand the next great factor, the creatures themselves, many of whom choose visibility only on their own terms, glowing not with sunlight but with the strange internal fire of bioluminescence that makes the darkness less empty and more alive. When sunlight no longer reaches, the ocean does not remain completely dark. Instead, it becomes alive with lights of a different kind, lights that do not come from the sky, but from the bodies of creatures themselves. In the absence of day, bioluminescence becomes the signature of survival, a strange, quiet form of energy release that flickers, glows, pulses, and sometimes dances across the black water. If the abyss is reluctant to reveal its secrets, then the creatures that glow in the dark are the reluctant storytellers, offering signals on their own terms, brief glimpses into a hidden world that thrives without the sun. Bioluminescence is not rare or exotic in the deep. It is common, perhaps one of the most widespread traits in midwater and abyssal life. From the smallest plankton to the largest predators, the ability to produce light independently has evolved over and over, in different families, for different reasons. What connects them is necessity. In the blackness, light is currency. It can lure, warn, confuse, seduce, or conceal. Each flicker has meaning, though much of it remains untranslated to us. For the animals, light is language. For us it is only a glimpse of their presence, one of the few ways they betray themselves to human eyes. Imagine drifting in a submersible with the lights turned off. At first, the darkness seems complete. Nothing moves, nothing stirs. Then a faint flash interrupts the void like a firefly in water. Another spark follows, then a ribbon of blue pulses in the distance. A shape glows faintly, almost transparent except for its lit-up organs. Tiny points blink like stars scattered across the void. Slowly you realise you are surrounded not by emptiness, but by an ocean filled with lights of its own making. The sea is not silent. It is whispering in signals you don't understand. For some creatures, bioluminescence is a lure. The anglerfish is perhaps the most famous example, with its modified dorsal spine that dangles like a glowing fishing rod just above its mouth. Small prey, attracted by the promise of light in endless night, drift closer, close enough to be swallowed whole by jaws lined with teeth. To us it seems sinister. To the anglerfish it is simply survival, an efficient trick in a world where food is scarce. Many other fish use similar strategies, lighting up parts of their bodies to attract the curious or to distract long enough to strike. Others use bioluminescence as defense. Certain squid eject clouds of glowing fluid the way their shallow water relatives eject ink. Instead of darkening the water, they brighten it with sparkling distractions, confusing predators long enough to escape. Some fish have photophores, small light-producing organs along their bodies, which can suddenly flare to startle attackers. Even jellyfish employ glowing displays, some pulsing with waves of light that ripple outward as a form of intimidation, making themselves appear larger and more threatening. In the dark, light becomes a weapon as much as a signal. For many species, light functions as camouflage through counter-illumination. At first, that idea seems backwards. How can producing light make you less visible? But in the mid-water zone, predators often hunt by looking upward, scanning for silhouettes against the faint downwelling glow from the surface. A fish that produces just the right amount of light from its belly can erase its own shadow, blending into the background and vanishing from sight. Some squid are experts at this, adjusting their glow to match the brightness above them. In that way, bioluminescence is not about being seen, but about not being seen. It is camouflage by imitation of the ocean itself. Then there is communication. Many organisms use light to find mates in the blackness. Some species of deep-sea shrimp signal with coded flashes, recognizable only to their own kind. Certain fish pulse patterns along their sides, broadcasting their readiness to reproduce. Even plankton may flash in waves, creating glowing tides that ripple across the sea surface when disturbed. In each case, light is a message. We don't yet know the full vocabulary, but it is likely rich, nuanced, and essential. What to us seems like random sparkles may to them be conversations as complex as birdsong. What makes these glowing creatures so mysterious to us is not only their beauty, but also their elusiveness. Bioluminescence is fragile. The chemical reactions that produce it often depend on delicate enzymes or symbiotic bacteria. Many of these fade quickly when removed from their natural environment. By the time specimens reach the surface, their lights may be gone, their organs collapsed, their bodies too damaged to study properly. The very trait that could help us identify them disappears before we can record it fully. As a result, many glowing species remain undescribed or only partially known. We have images, we have fleeting videos, but we lack complete understanding. Even the basics are uncertain. Scientists estimate that the majority of midwater creatures may be bioluminescent, but no one knows the exact percentage. Each expedition adds new data, but the ocean's vastness makes comprehensive surveys impossible. In some regions, glowing plankton dominate. In others, glowing fish. In others, jellies that pulse rhythmically. The patterns shift with currents, depth, season, and even time of day. The largest migration on Earth, the daily rise and fall of plankton and fish from the deep to the surface, is itself illuminated by bioluminescent trails. But because it happens mostly at night, far offshore, we rarely see it. For humans, encounters with glowing creatures are often accidental. Swimmers in tropical bays sometimes stir bioluminescent plankton with their movements, leaving sparkling trails behind. Surfers may carve glowing wakes in the water. Ships crossing certain seas at night can appear to cut through fire, their hulls surrounded by glowing foam. These spectacles are unforgettable, but they represent only the faintest suggestion of what happens constantly in deeper waters. The true light show, hidden below, is one we rarely witness directly. This is another reason why so many species remain unknown. Their main method of signalling is light, but our main method of study is collecting, and the two do not align. Nets destroy fragile bodies. Lights disrupt natural displays. Cameras capture only small fields of view. Much of the glowing world remains invisible, not because it lacks light, but because its light is fleeting and context-dependent. Without the right conditions, it disappears. It's fascinating to think about how bioluminescence has influenced human imagination. Myths of glowing seas, tales of ghostly lights in the water, even modern science fiction often borrow from these real phenomena. Aliens imagined as glowing, tentacled beings are less invention than reflection of creatures that already exist in the deep. Fireflies of the land are enchanting, but the ocean holds billions of fireflies of countless shapes and purposes, drifting silently in the black. And yet, because they remain hidden from daily life, they still feel alien to us, even though they are part of our planet. The chemistry behind bioluminescence is fairly well studied in some species. The reactions usually involve a molecule called luciferin, which reacts with oxygen under the control of an enzyme called luciferase. The result is the release of photons, cold light, efficient and precise. Some organisms produce their own luciferin, others obtain it from diet or symbiotic microbes. But beyond these commonalities, the mechanisms vary widely. Different lineages have evolved bioluminescence independently dozens of times. This repeated evolution suggests that in the dark ocean, light is such a powerful advantage that nature invents it again and again. Still, the specifics for many species remain unknown, another reminder of how incomplete our knowledge is. In many ways, bioluminescent creatures highlight the paradox of ocean exploration. We know the phenomenon is widespread, yet we cannot quantify it. We see flashes, but not the full context. We understand the chemistry in some cases, but not the ecology in most. We can record video, but often in artificial settings. Each glowing body is a reminder that the deep sea lives on its own terms, not ours. And until we can observe without disrupting, much of that glowing language will remain untranslated. There's also something humbling about realizing how ancient this adaptation is. Bioluminescence is thought to have evolved hundreds of millions of years ago. Long before humans walked the land, long before dinosaurs ruled the surface, the deep sea was glowing. Generation after generation, creatures communicated in sparks and glimmers, indifferent to the land above. That ancient continuity continues now, invisible to most of us, but unbroken. Every time a jelly pulses or a fish flares, it is part of a tradition older than humanity. That perspective adds weight to each discovery. When we film a glowing shrimp, we're not witnessing novelty. We're witnessing something that has shaped life for eons, finally revealed for a moment to us. And yet, the reluctance remains. Creatures that glow do not glow for us. They glow for each other, for survival, for reproduction, for defense. We are bystanders who catch glimpses by luck or by intrusion. Their lights are not performances for our cameras, but survival strategies in a dark and endless sea. That mismatch ensures that much of what we crave to know will remain incomplete. Their secrets multiply not because they are intentionally hidden, but because their signals are not meant for us. Still, the fact that they exist at all broadens our imagination. Knowing that the sea glows from within changes how we think of life on Earth. It prepares us for the possibility of life beyond Earth too. If creatures can thrive in dark oceans here, glowing without sunlight, then perhaps similar strategies could emerge elsewhere, in subsurface oceans of icy moons, or in distant seas orbiting alien suns. The glowing creatures of our own world are reminders that life is not limited to the rules we assume. As we drift onward through this long exploration of why so many ocean creatures remain unknown, the glowing inhabitants are both exception and rule. Exception, because they reveal themselves with light. Rule, because even that light is partial, coded, fleeting. For every creature we see flare in the dark, there are countless others that glow unseen, their messages carried out in silence, their presence multiplied by secrecy. And in that awareness, we are prepared to look more closely at how the ocean communicates without light as well, through vibration, through sound, through pressure waves. Because once we leave the realm of glowing creatures, we enter the vast silence of the depths, where vision is no longer king at all, and sound becomes the primary sense by which both predators and prey find their way. If vision becomes unreliable as light fades, then another sense takes its place in the deep. In the absence of sight, the ocean turns to sound. For us, the depths might feel silent, a place of emptiness, because we imagine silence in terms of what we can hear. But to the creatures who live there, the water is alive with vibrations, echoes, pulses and rhythms. Sound rules where light disappears. And it rules not only because it travels differently underwater, but because it carries meaning over distances that no flash of light could ever reach. Sound in water behaves in ways that surprise most people. In air, sound travels at about 340 meters per second. In water, it moves more than 4 times faster. It also travels farther, carrying across kilometers with little loss. That difference means that in the ocean, sound is the most efficient way to sense, to communicate, and to navigate. Even in pitch blackness, even under crushing pressure, sound cuts through, connecting creatures separated by huge stretches of water. For the animals adapted to it, the deep is anything but silent. It is a world stitched together by acoustics. Whales provide the most famous example. Blue whales, the largest animals on Earth, produce calls that can travel hundreds of kilometers, sometimes more than 1,000. Their low-frequency rumbles pass through the depths, reaching potential mates far beyond visual range. Sperm whales use powerful clicks to hunt, sending out pulses that bounce back from prey, allowing them to detect squid in total darkness. These same clicks are among the loudest biological sounds on the planet, sometimes powerful enough to be felt through the hulls of ships. To humans, hearing a whale call is awe-inspiring. To whales, it is daily communication, essential for survival in a dark expanse where no eye can see far. But whales are not alone. Many fish produce sounds by grinding teeth, vibrating swim bladders, or snapping specialized parts of their bodies. Shrimp create sharp cracks that can stun prey. Some deep-sea creatures generate low rumbles, others high-pitched squeals, each adapted to their ecological niche. Taken together, these create what scientists call the biophony of the ocean, a soundscape produced by living things, as complex as any forest chorus. Add to that the geophony, the sounds of geological activity like earthquakes or venting, and the anthropophony, the sounds of human ships and machinery, and the deep is anything but silent. It is a layered sound world where every vibration matters. For creatures who inhabit it, sound is both map and message. Many fish detect pressure changes through lateral lines, rows of sensory organs along their bodies. These organs pick up vibrations as subtle as the ripple of a passing school or the movement of a predator's fin. To us, such faint signals are invisible. To them, it is constant awareness, a form of vision made of touch and sound. In the deep, where silence to us feels absolute, animals are surrounded by a stream of sensory input, one we're only beginning to understand. This reliance on sound is one of the reasons so many ocean creatures remain mysterious. Our methods of study are biased toward light. We build cameras, we shine beams, we seek to see. But in the ocean, most interactions are acoustic. Without the ability to translate those signals, we miss much of the story. When a pod of whales sings, we can record it, but we don't fully know what the patterns mean. When shrimp snap, we hear the noise, but we can't trace every consequence. Whole layers of communication happen beneath our perception, leaving species unknown not because they don't exist, but because their presence is marked by sounds we can't yet interpret. The ocean even shapes how sound moves depending on depth and temperature. There is a phenomenon called the SOFAR channel, a layer where sound waves can travel exceptionally far because of the way pressure and temperature interact. Many marine animals take advantage of this channel, sending signals that can carry across ocean basins. For us, it has been useful in navigation, even military detection. But for creatures, it is a natural highway of communication, a way to remain connected in an environment too vast to cross by sight or touch. Understanding this acoustic dimension is crucial, yet our knowledge is still limited. Every new study reveals complexities we hadn't imagined, signals used in mating rituals, in group hunting, in warning systems, all hidden in what we once called silence. The irony is that when humans first lowered microphones into the sea, they expected quiet. Instead, they found a cacophony. Whistles, moans, crackles, groans, an entire spectrum of sound we had never noticed. That discovery was both thrilling and disorienting. If so much was happening beyond our hearing, then how much more might still be happening beyond our interpretation? Sound reminded us that the ocean is not an empty void, but a crowded, active space. Yet, because most of this sonic world is outside our normal senses, it remains mysterious, and the creatures producing it remain unknown. Sound is also tied to survival strategies we are only beginning to appreciate. Some predators, like dolphins, use echolocation so precise they can detect the shape and size of objects meters away. Some fish may use low-frequency calls to coordinate schools, moving in synchrony without ever seeing one another. Even the smallest organisms, like plankton, may respond to vibrations, shifting behavior in ways that ripple through ecosystems. To study these effects, we need sensitive hydrophones and careful analysis. But the ocean's soundscape is so vast, so constant, that isolating individual signals is a daunting task. The more we listen, the more we realize how little we understand. Adding to the complexity is human noise. Ships, submarines, drilling, sonar, all of these create sound that interferes with natural communication. To us, it may be background hum. To animals, it can be overwhelming. Some whales have been forced to change the pitch of their calls to be heard over shipping noise. Some fish abandon habitats too loud for effective signalling. This interference makes it even harder for scientists to study natural soundscapes. The creatures themselves may alter their behavior in ways we misinterpret, leaving us with partial or misleading pictures of their lives. Once again, our presence distorts the very signals we are trying to understand. Yet even with interference, the ocean's acoustic richness persists. Consider the mysterious bloop, a low-frequency sound detected in the 1990s by ocean monitoring equipment. At first, it puzzled researchers. Too loud to be a known animal, but too organic to be a simple geological event. Speculation ranged from giant squid to massive unknown creatures. Eventually, it was attributed to icequakes, the fracturing of icebergs. But the fact that such a sound could spark serious consideration of undiscovered animals illustrates how much the acoustic dimension fuels mystery. Every strange noise reminds us of possibilities beyond our current grasp. Sound also reveals life in places where sight would never help. In trenches miles deep, hydrophones have detected clicks and moans from animals far below where light can reach. Some of these signals belong to known species, like sperm whales diving for squid. Others remain unassigned, patterns without names, belonging to creatures we have yet to identify. For every whale we can recognize by song, there may be dozens of animals producing signals still uncatalogued. The darkness may hide them, but sound betrays their presence. And yet, because we cannot always match sound to body, they remain mysteries, voices without faces. For humans, trying to translate these acoustic worlds is humbling. We can record hours of whale songs, but decoding their full meaning remains out of reach. We can map soundscapes, but understanding individual contributions is still new. The ocean resists easy interpretation, not only through distance and darkness, but through languages we don't speak. That resistance ensures that many creatures remain unknown, existing in frequencies and patterns that pass unnoticed by us, even as they dominate the lives of those who live below. What makes the silence of the depths so striking is not its lack of sound, but its lack of sound in our terms. To us, silence means absence. To the ocean, silence means hidden presence. The rules are different. Vibrations matter more than visibility. Echoes replace outlines. For us to understand the ocean better, we have to shift perspective, to admit that our strongest sense, vision, is not the strongest sense there. In making that admission, we also admit that our knowledge will always be incomplete. And so, when we ask why most ocean creatures remain unknown, part of the answer lies here. They live in a world structured by sound, not light, and we are slow learners in that medium. We can see far with telescopes, but we cannot hear far with the same clarity. We are sight-driven beings in a sound-driven ocean. Until we fully adjust, until we learn to listen as well as we look, much will remain hidden. That hiddenness is not failure. It is part of the ocean's design. Mystery multiplies in darkness, and sound ensures that much of it will stay coded. But even as we acknowledge that, we also see how adaptable life is. Creatures not only endure silence, they thrive in it, turning it into a rich network of signals we're only beginning to overhear. That adaptability prepares us for the next challenge. Because if sound rules where silence seems to reign, then pressure rules everywhere else, shaping every living body, every piece of machinery, and every attempt to descend. Every meter you descend beneath the ocean's surface adds weight. At 10 meters, the pressure doubles what we feel on land. At 100, it's 10 times greater. By the time you pass 1,000 meters, the water pressing against every part of a body or vessel is 100 times more forceful than the atmosphere above the ground. Keep going, and the numbers climb until they defy imagination. At the very bottom of the deepest trench, the pressure is over 1,000 times what you experience at the surface. It is like stacking entire skyscrapers of water on top of you, an invisible weight that never relents. This constant, crushing force turns the sea into a fortress, not out of hostility, but out of simple physics. And it is this fortress-like quality that has kept most of its creatures hidden from us. For us, pressure is usually not noticeable. We live within one atmosphere of it, breathing comfortably, walking without thought. At high altitudes, we notice thinner air, but not crushing force. The ocean, however, is relentless. It does not forgive even slight weaknesses in design. If you take a sealed container down too deep, it will implode suddenly, collapsing inward with enormous violence. Submersibles must be built like armour, with thick hulls, perfectly rounded to distribute pressure evenly, because the ocean exploits flaws without hesitation. A single crack or seam can be catastrophic. That harsh demand for perfection is why so few vessels have ventured deep, and why so few people have personally witnessed the abyss with their own eyes. But pressure doesn't only restrict machines, it dictates biology as well. Animals that live under these conditions have adapted in extraordinary ways. Their proteins, for example, are structured differently so that they do not denature under pressure. Their cell membranes remain flexible, despite forces that would normally solidify them. Some deep-sea fish rely on compounds like trimethylamine oxide, which stabilize proteins at high pressures. To them, this fortress is not hostile but natural. They are born into it, shaped by it, thriving in a place where we cannot survive. For us, it is a barrier. For them, it is simply home. and this barrier explains much of why so many ocean creatures remain unknown. We cannot bring them easily to the surface, remove the pressure, and their bodies collapse, their biochemistry unravels, their very structures fail. The gelatinous tissues of some deep-sea animals, designed to balance perfectly against external force, disintegrate when that force disappears. Specimens caught in nets often arrive as unrecognizable mush, their shapes destroyed by the journey upward. Even when scientists manage to collect intact samples, keeping them alive at surface pressure is nearly impossible. Special pressurized tanks exist, but they are rare, costly, and can only hold a few species at once. That fragility means much of the abyss remains glimpsed but not studied in full. We know the animals are there, but we cannot bring them into our world long enough to understand them. Consider the example of the Hadal snailfish, one of the deepest living fish discovered. It thrives in trenches at depths beyond 8,000 meters, where pressure is unimaginable. Its body is soft, almost translucent, lacking the rigid structures we associate with fish near the surface. Instead, its very flexibility allows it to survive. Yet when researchers bring it up, even carefully, it often falls apart. Only by designing equipment that maintains pressure during ascent have we been able to keep specimens intact for any length of time. These breakthroughs reveal fragments of their biology, but the broader picture remains hidden. For every snailfish we've studied, countless other trench dwellers have never been seen alive by human eyes. Pressure also limits how long we can stay in the deep. A submersible may descend to several kilometers, but the engineering challenges are immense and missions are short. Supplies run out, risks accumulate, and costs mount. Unlike satellites that can orbit for years, deep-diving vehicles spend only hours on the bottom before they must rise again. That brevity means observations are fleeting. A few hours in a world that spans millions of square kilometers ensures that most of its creatures will remain unseen. The fortress allows brief visits but never permanent settlement, and even our most advanced technologies face the same wall. ROVs and AUVs, remotely operated and autonomous underwater vehicles, are marvels of engineering, but they too must withstand crushing forces. Their cameras, sensors and manipulator arms all require housing that resist collapse. The deeper they go, the more expensive and fragile they become. A single implosion can end a multi-million-dollar mission. These limitations mean that expeditions are rare and cautious. We choose sites carefully, explore slowly, and accept that what we see is only a fraction of what is there. The fortress is not breached easily, and the cost of each breach is high. This pressure barrier also explains why so many deep-sea myths persisted for so long. Sailors could describe strange shapes on the surface, giant tentacles, shadows beneath the waves, but without a way to confirm them, such stories remained untested. Pressure prevented anyone from descending far enough to know for sure. Even today, some creatures are known only from fragments, bits of tissue or half-digested remains found in the stomachs of predators. The rest of their bodies remain invisible, concealed behind walls of water too heavy for us to penetrate. The ocean's fortress is not uniform. In some regions, pressure combines with extreme cold and low oxygen, creating triple barriers. Life in these zones must cope not only with crushing force, but with limited energy and respiration. Yet life persists, finding niches where we assumed none existed. Each discovery underlines how incomplete our assumptions have been. The fortress does not prevent life, it prevents us from knowing life. What makes pressure such an effective barrier is its invisibility. You cannot see it or feel it until you are immersed in it. To a diver, the ocean surface looks harmless, inviting. But descend beyond limits, and suddenly lungs cannot expand, ears ache, equipment fails. By the time you reach even modest depths, pressure becomes an undeniable force. Beyond that, it becomes catastrophic. It is this hiddenness that makes the fortress so formidable. It doesn't announce itself. It simply exists everywhere, waiting. and yet the creatures adapted to it live as if nothing is extraordinary. Amphipods scuttle across trench floors, eelpouts swim leisurely. Bacterial communities thrive in sediments, dividing endlessly in conditions that would destroy surface microbes. For them, pressure is not an obstacle, but a constant backdrop. The fortress is not closed to them, it is closed to us. And that difference defines the mystery. We cannot fully know a world where our very bodies cannot function. Still, technology advances slowly. Some experiments now use lander vehicles, free-falling platforms that descend into trenches, release bait, and film whatever arrives. These have captured images of fish, crustaceans, and scavengers at depths once thought sterile. Yet even then, the footage is brief, limited to the area around the bait. The fortress reveals only what comes close, not the broader ecosystem. It is like peering through a keyhole into a cathedral, catching details but never the whole. This constant limitation ensures that most abyssal and hadal species remain undescribed. Even when we record them, naming and classifying requires more than an image. It requires physical specimens, detailed anatomy, genetic analysis. Without those, we cannot place them properly in the tree of life. But because pressure prevents easy collection, many animals exist only as blurred shapes on video, tantalizing but incomplete. They remain nameless presences, their existence acknowledged but their identities unknown. Think of how much we have learned from just a handful of dives. The Challenger. Deep, the deepest part of the Mariana Trench, has been visited only a few times by humans. Each visit has produced new data, surprising observations, and sometimes unexpected debris from human activity. If so few dives into a single site reveal so much, imagine what remains unseen in the hundreds of other trenches, ridges, and plains we have never entered. The fortress keeps its secrets not by absence but by abundance, locked away behind pressure. This barrier doesn't just affect science, it affects imagination. We picture space exploration as difficult but possible, given enough rockets. We picture deep-sea exploration as alien, almost unattainable, because of the crushing conditions. That perception shapes funding, priorities, and cultural focus. The fortress wins twice, by physically excluding us and by discouraging us psychologically. Its sheer presence tells us to look upward instead of downward. That tendency is part of why ocean creatures remain unknown. We simply don't try as often. Yet every breakthrough shows that persistence pays. The discovery of hydrothermal vents, the recording of giant squid, the cataloguing of trench snailfish, all were possible because engineers and scientists pushed against the limits of pressure, and each time the reward was more than new species. It was the reminder that the fortress is not impenetrable. It is difficult, costly and slow, but not absolute. It can be entered in fragments, it can be negotiated, and each negotiation yields surprises that expand our sense of what life can endure. The truth remains, though, that pressure ensures mystery will never fully disappear. Even if technology advances, even if we can descend routinely, the adaptations of life to this environment are so extreme that many species will never survive the transition into our world. They will always remain bound to theirs, creatures of the fortress, glimpsed only when we descend carefully into their realm. That inevitability means the unknown will always persist, preserved by the physics of water itself. And it is in this persistence that we find the thread leading onward. Because once we acknowledge that the fortress will never yield completely, we begin to appreciate the ways animals themselves make the most of it. They do not simply endure pressure, they use it. They evolve strategies of camouflage, disguise, and deception that make them even harder to notice. Just as the ocean shields them with darkness and pressure, they shield themselves with tricks of invisibility, ensuring that discovery remains rare and partial. When you enter the ocean, even in its shallowest reaches, you quickly notice how much effort is devoted to hiding. Fish that match the sand, crabs that resemble rocks, octopuses that change shape and colour in an instant. All of them treat visibility as a liability. In the deep sea, this tendency multiplies into an art form. Camouflage and disguise are not occasional tricks, they are the rule, woven into every layer of survival. To remain alive, many creatures must avoid detection at all costs, and in a world of fading light and constant threat, the dance of invisibility is performed on a stage where every movement is life or death. Camouflage begins with colour, though in the deep it doesn't work the same way as on land. In shallow waters, tropical fish use bright patterns to confuse predators, blending with corals and shadows. But in the twilight zone, red becomes the colour of invisibility. Because red light does not penetrate far, animals with red bodies appear black in the dim blue gloom. Shrimps, worms and fish often adopt this hue, rendering themselves nearly invisible. To our eyes under artificial light they seem vivid and strange. In their natural setting they disappear. It's a clever inversion. The brightest colour in sunlight becomes the darkest cloak in shadow. Transparency is another widespread strategy. Many deep-sea animals are almost completely see-through, their tissues allowing light to pass through with minimal reflection. Jellyfish, comb jellies, larval fish, even some squid all use this method. To spot them, you often need a light at just the right angle to catch a glimmer of internal organs or faint outlines. Otherwise, they vanish against the background of water. Transparency is perhaps the most perfect camouflage, because it removes the very surface predators could see, but it comes at a cost. Transparent bodies are fragile, delicate, prone to damage when disturbed. This fragility is one reason they remain so poorly studied. Nets tear them apart, handling destroys them, even water turbulence can shred their forms. They are designed to vanish, and that vanishing often extends to our attempts at study. Then there is countershading, a more familiar method. Many fish are dark on top and light on the bottom, making them blend whether seen from above or below. In the ocean's dim layers, this patterning becomes especially important. A predator scanning upward might see only a pale belly blending into faint light from the surface. A predator scanning downward sees a dark back merging into the blackness below. In both cases, the fish disappears into its background. It's such an effective strategy that it has evolved independently in countless lineages, from sharks to squid to lanternfish. But in the deep, camouflage goes beyond these basics. Some species use bioluminescence not to reveal themselves, but to erase themselves. By producing light from photophores on their undersides, they cancel out their shadows against the faint glow above. This counter-illumination makes them invisible to predators looking upward. Adjusting the brightness of their light, they can fine-tune their disguise to match the background. It's a living invisibility cloak, dynamic and precise. To study it, scientists must use specialized low-light cameras, because ordinary lights make the trick useless. Under artificial beams, the animals glow vividly. In their natural context, they vanish completely. Other disguises rely on mimicry. Some animals imitate inanimate objects, bits of detritus, drifting algae, even marine snow. Larval fish may dangle long filaments to resemble jellyfish tentacles, deterring predators who avoid stinging creatures. Some squids elongate their bodies and drift passively, mimicking floating debris. Predators pass them by, assuming they are unimportant. In the deep, where energy conservation is vital, such deception can mean the difference between survival and death. Mimicry also confounds scientists. Identifying a species that looks like something else is doubly difficult when encounters are brief and fragile. Many animals remain misclassified or undiscovered simply because their disguises work too well. The ultimate masters of disguise are cephalopods, octopuses, squids and cuttlefish. Even in the deep, where colour perception is limited, their ability to change texture and form makes them formidable tricksters. They can flatten against the sea floor, ripple their skin to match rocks, or balloon into spiny shapes to deter attack. In some cases, they use bioluminescence to add to the performance, pulsing with light while shifting body form. Watching one transform is like witnessing a magic trick, a rapid rewriting of identity. To predators, this creates hesitation, enough time for escape. To us, it creates fascination but also frustration, because classification depends on consistent traits, and these animals refuse to be consistent. They remain elusive not only in behaviour but in identity. Camouflage also explains why so many deep-sea species are still undocumented. If you rely on visual surveys, you will miss most of what's there. A transparent jelly drifting nearby might go unseen. A red shrimp may be invisible against black water. A glowing fish might switch off its light before the camera turns its way. Each of these tricks reduces the likelihood of discovery, ensuring that our catalogues remain incomplete. Every survey is biased by what we can see, and camouflage ensures that what we can see is only a fraction. In addition, disguise operates at scales we don't usually consider. Microscopic plankton use transparency, pigment shifts, and even reflective surfaces to remain undetected. Some single-celled organisms build shells of silica or calcium that make them resemble grains of sand. These disguises reduce predation but also reduce visibility to scientists collecting samples. Even at the tiniest level, life in the ocean invests in being unseen. The result is a vast portion of biomass hidden not by distance but by strategy. The evolutionary arms race driving these disguises is relentless. Predators evolve sharper senses, prey evolve better camouflage. In the absence of light, sensitivity shifts to motion, vibration, and faint glows. To counter this, animals refine their disguises to the smallest detail. Some fish have scales that scatter light in ways that minimize reflection, making them nearly invisible even to sensitive eyes. Others position themselves in shadows, moving slowly to avoid disturbance. Over millions of years, this constant competition has produced a repertoire of disguises so varied that even when we do encounter these creatures, we often don't realize it. Many discoveries are delayed simply because observers thought they were looking at debris or at already known species. And then there are the disguises that are not physical but behavioural. Some fish remain motionless for long periods, avoiding detection by stillness. Others hide within schools of unrelated species, blending into a moving crowd. Some mimic the behaviour of toxic or inedible animals, adopting their swimming style or posture. These tactics make classification even more complex. To recognise a new species, you need to observe consistent behaviour, but in the ocean, consistency is often sacrificed for deception. The animals prioritise survival over clarity, leaving scientists to piece together identities from fleeting moments. Camouflage also plays into reproduction. Many species release larvae that look nothing like adults. These young forms often have transparent or elongated bodies, drifting with plankton, disguised as harmless drifters. Only later do they transform into recognizable adults. That means a larva collected at the surface might not be identified as belonging to a known species for years, until someone connects the stages. In the meantime, it sits in collections as an unknown, one more mystery preserved by disguise. The combination of all these strategies makes the deep ocean one of the hardest environments for cataloguing life. It's not just vastness, not just darkness, not just pressure, it's also intentional invisibility. The creatures themselves are participants in their own concealment. Discovery is not only difficult but resisted. The ocean doesn't give up its secrets easily, and its inhabitants have spent millions of years perfecting the art of remaining hidden. For humans, this creates a paradox. We are drawn to the spectacular, the glowing jelly, the dramatic squid, the unusual fish. But these are often the exceptions, the ones who reveal themselves despite camouflage. The majority remain unnoticed, their disguises working so well that they slip past even our most advanced instruments. The more we learn about their strategies, the more we realise how much we have missed. Entire groups may remain undescribed simply because they are too well hidden. What we do know suggests that camouflage in the deep is not static. It shifts with context. Some animals change patterns depending on depth. Others adjust transparency depending on light angle. Still others coordinate disguises with behaviours, making the dance of invisibility a complex performance of constant adaptation. Studying such fluidity requires repeated encounters, but encounters are rare, so most of this complexity remains hypothetical. For every confirmed example, many more are suspected but unproven, and so the dance of camouflage and disguise ensures that the unknown stays plentiful. It's not just that we haven't looked enough, it's that even when we look, the ocean answers by hiding. This is why discovery in the deep sea feels like revelation. Every new species described is not just a scientific note, but a brief interruption of a performance designed to avoid our gaze. Every find is accidental, the result of a moment when disguise faltered or curiosity outpaced caution. That rarity is what keeps the ocean so mysterious. Camouflage ensures that mystery is not a temporary condition, but a permanent state. As long as animals continue to disguise themselves, as long as the deep provides a stage for invisibility, most of its inhabitants will remain beyond our sight. And even when we begin to detect them, new disguises will evolve, keeping the balance tilted towards secrecy. It's in this endless dance that we find the thread leading forward, because if creatures hide themselves so effectively, then even the smallest among them may hold secrets we have never uncovered. Tiny lives, invisible and fragile, make up the majority of the ocean's diversity. And while we're often captivated by giant squid and luminous fish, the next barrier to understanding lies in those minute, overlooked beings whose mysteries are just as profound. When most people think of the ocean, they imagine whales breaching, sharks gliding, or octopuses vanishing into rocky crevices. The image is dominated by the large and dramatic, but in truth, the overwhelming majority of ocean life is tiny, often too small for the eye to detect without help. Plankton, microbes, larvae, and microscopic drifting organisms make up the real bulk of biodiversity and biomass in the sea. They are the foundation upon which everything else depends, and yet, these small lives carry mysteries just as enormous as any giant predator. In many ways, they are even harder to know. Plankton is a word that comes from the Greek for drifter, and that is exactly what they are. Creatures carried by currents, unable to swim strongly enough to control their position. Some are plants, or more precisely phytoplankton, single-celled organisms that photosynthesize and produce much of the oxygen we breathe. Others are animals, zooplankton, ranging from tiny protozoans to the larval forms of fish, crabs, and mollusks. Together they form a living soup that fills the ocean's upper layers. Every mouthful of seawater contains thousands of them. Yet despite their abundance, the diversity of plankton is staggering, and much of it is still undescribed. Scientists regularly identify new species under microscopes or through genetic analysis, suggesting that the richness of these small lives is far beyond what we have catalogued. The mystery of plankton lies not only in their variety but in their role. They form the base of the marine food web, feeding everything from sardines to whales. Without them, the ocean would collapse, but their populations are influenced by currents, nutrients, temperature, and light in ways that are complex and often unpredictable. Some years they bloom in massive numbers, colouring the sea green or red. Other years they decline. These shifts ripple upward through the entire ecosystem, affecting fish stocks, seabirds, and even global climate. Yet our ability to predict or fully understand these patterns remains limited. For all our satellites and sampling equipment, plankton communities still move according to rules we barely grasp. They are tiny, but their mysteries shape the fate of oceans and humans alike. What makes studying them so challenging is their fragility. Many plankton are too delicate to survive standard nets, breaking apart into fragments before they can be identified. Others look identical under a microscope, requiring genetic sequencing to distinguish. Still others exist in forms so fleeting, larvae that last days or weeks. that by the time they are noticed, they have already transformed into something else. In this way, plankton slip through our scientific grasp as easily as they drift through currents. The ocean is filled with their presence, yet they remain elusive. A hidden majority we only glimpse in pieces. Among the most enigmatic are the larval stages of larger animals. A fish may lay eggs that hatch into larvae looking nothing like the adult. Some are elongated with bizarre filaments trailing behind them. Others are transparent, with oversized eyes or spines. To the untrained eye, they seem like alien species. For decades, many larval forms were classified as entirely new animals, only later revealed to be the early life stages of known fish. Even now, many larvae collected from the sea cannot be matched to adults. They sit in specimen jars as mysteries, their identities unsolved. Each one is a reminder that even familiar animals hide secrets when young. Microbes add another layer. The ocean is filled with bacteria, viruses and archaea that form invisible communities influencing everything from nutrient cycles to climate. Some live freely, others attach to particles, others inhabit the guts of plankton or fish. Collectively, they are essential to the health of the ocean, and yet we know only a fraction of their diversity. Genetic surveys suggest millions of distinct microbial species exist in seawater, most never cultured or described. Some of these microbes may play roles in regulating carbon storage, others in breaking down pollutants, others in creating toxins that ripple through food chains. Their impact is vast, but because they are so small and so numerous, their mysteries remain vast as well. Viruses in particular are astonishing. Ocean water contains more viruses than any other entity, billions in every litre. Most are harmless to humans, targeting bacteria or plankton instead. They regulate populations by infecting and killing their hosts, shaping community structure on a microscopic scale. Without them, plankton blooms might overwhelm ecosystems. With them, balance is maintained. Yet the vast majority of these viruses have never been studied. Their genetic codes remain unread, their dynamics uncharted. They are the invisible regulators of ocean life, powerful yet largely unknown. The more we look, the stranger it becomes. Consider the discovery of giant viruses in the sea, some with genomes larger than those of many bacteria. These challenge our understanding of what a virus is, or the symbiotic microbes that live inside tube worms at hydrothermal vents, providing them with energy in the absence of sunlight, or the bacteria that metabolize methane seeps, preventing greenhouse gases from entering the atmosphere. Each microscopic partnership carries consequences far beyond its scale. These tiny lives influence the planet's climate, its chemistry, and its stability. And yet most of their identities remain hidden, their mysteries enormous. What makes their study even more pressing is their sensitivity. Small changes in temperature, acidity, or nutrient availability can ripple through plankton communities dramatically. Climate change alters ocean chemistry in ways we cannot yet predict fully, and plankton respond in ways that affect everything above them. A slight decline in phytoplankton productivity could reduce oxygen production on a planetary scale. A shift in zooplankton populations could collapse fisheries. These are massive consequences driven by creatures too small to see. The stakes of their mysteries are planetary. For humans, it is often easier to focus on the charismatic megafauna, the whales, the sharks, the giant squid. But the real frontier lies in the micro. Every litre of seawater holds more life than entire forests, compressed into scales too small for our eyes. Each droplet is a universe of drifting, fragile beings, each with its own lineage, adaptations and roles. And because they are so small, so numerous and so variable, our attempts to know them lag far behind. The unknown ocean is not only in the abyssal depths or behind walls of pressure, it is in every bucket of seawater, every unseen life drifting by unnoticed. Studying these creatures requires tools far different from those used for larger animals. Microscopes, DNA sequencers, flow cytometers, machines that can sort and identify organisms by the thousands in minutes. And yet, even with these, we fall short. The sheer diversity overwhelms. The genetic codes we recover hint at lineages never named, branches of the tree of life unmarked. Some researchers call it the microbial dark matter, the enormous portion of genetic diversity in the ocean we know exists but cannot yet describe. That phrase captures the mystery well. Just as astrophysicists speak of dark matter in space, oceanographers face dark matter in biology. It is everywhere, unseen and essential. And while their scale is small, the strategies they use are extraordinary. Some microbes can survive in near-boiling vent fluids, others in supercooled brines under Arctic ice. Some produce antifreeze proteins, others thrive without oxygen. Some form biofilms on rocks miles below the surface, eking out existence in near-total isolation. Each adaptation tells a story of survival against odds. Each raises questions about the limits of life. If microbes can thrive in such extremes here, perhaps they could thrive in oceans beneath the ice of distant moons. Tiny lives here become clues to possibilities elsewhere, their mysteries extending beyond Earth. One of the reasons tiny lives remain mysterious is that they resist our ways of knowing. We want to classify, label, categorize, but microbes exchange genes freely, blur boundaries, and evolve rapidly. Plankton populations bloom and collapse in cycles that don't fit neat categories. Larvae shift shapes dramatically before settling into adulthood. All of these resist easy labels, ensuring that our taxonomies remain incomplete. The very fluidity of their existence makes them mysterious. And perhaps most humbling is the realization that we have been swimming among these creatures all along without noticing. Every time you taste the salt of seawater, you're tasting a solution shaped by microbial processes. Every breath you take carries oxygen, much of which was produced by phytoplankton. Every fish you see is the product of a larval stage that once drifted unseen. The tiny lives sustain the giants, and the giants in turn sustain us. Yet we remain largely unaware of their specifics, their identities, their dynamics. We live by their grace while they remain unknown. When scientists lower fine nets into the sea and haul up samples, they're often struck by how alien the contents look. Transparent worms with feathery appendages, planktonic crustaceans with huge eyes, larval forms with spiny protrusions, and countless single-celled organisms glowing faintly or shifting with iridescence. Each jar contains dozens of species, many unclassified. The variety is overwhelming. Each toe of a net adds to the realization that the ocean is far stranger at the small scale than at the large. Yet because these beings are fragile and ephemeral, they often disappear before we can fully examine them. The mysteries multiply not because of rarity, but because of abundance and delicacy combined. So when we ask why so many ocean creatures remain unknown, we must remember that it is not only the giants hiding in trenches or the predators lurking in darkness. It is also the invisible multitudes drifting all around us. Their mysteries are enormous, not because they are large, but because their roles are vast. They control oxygen, carbon, nutrients, and the balance of ecosystems. And until we understand them fully, our picture of the ocean will always be incomplete. And from this scale of the tiny, we turn again to the immense. Because while fragile plankton and microscopic microbes carry mysteries by the billions, the ocean also holds enormous shadows, massive animals that slip away from observation despite their size. The unknown lives not only in the small, but also in the giant forms that vanish as easily as the plankton drift. When most people imagine unknown creatures in the ocean, their minds don't first go to plankton or microbes. They go to the giants, the enormous beings that drift or hunt in silence, vast bodies moving just beyond reach. There is something about scale that captures imagination. To picture a creature so large that it dwarfs our boats, or so elusive that it has never been seen alive in full, feels like touching myth. And yet, the truth is that such shadows exist. They slip away not because they are imaginary, but because their world is immense and they are masters at avoiding our notice. For centuries, stories of sea monsters haunted sailors. Enormous serpents coiled around ships. Krakens pulled sailors into the depths. Leviathans breached in storms. Many of these tales were exaggerations or misinterpretations, but they were also rooted in glimpses. A tentacle surfacing in the night, a shadow moving beneath a vessel, a carcass washed ashore in strange condition. Each was a fragment, incomplete, leaving the mind to fill in details. The giants of the ocean became figures of fear and awe precisely because they were seen only in parts, never whole. And that same elusiveness continues today. Take the giant squid. For centuries it was legend, a story told in hushed tones until fragments of its body began washing onto beaches, tentacles, beaks, eyes. Each piece suggested a creature beyond imagination with arms long enough to encircle small ships. But living proof remained out of reach. Nets sometimes hauled them up dead, often mangled. Whales carried scars of battles with them, evidence of life and death struggles in the dark. But only recently, with specialised cameras and patience, did we capture footage of these animals alive in their habitat. And even then the glimpses were brief, graceful, red forms drifting through the black, as if aware of their watchers but unwilling to linger. For a creature up to 13 metres long, the fact that it could remain unseen for so long is a reminder of how effective the ocean is at concealing its giants. The colossal squid, a relative even larger and heavier, is still more mysterious. Few intact specimens exist, and those we've examined suggest adaptations that defy expectation. Eyes the size of dinner plates, hooks on their tentacles, bodies built for battles in the freezing dark of Antarctic waters. Yet we have no footage of one alive, no direct observation of its behaviour. It remains, even today, a shadow in our records, known more through scars on predators and the occasional unlucky capture than through any real familiarity. That such a massive animal could remain unknown speaks volumes about the limits of our reach. And the squids are not the only ones. The deep-hide sharks of immense size. The sleeper shark, for example, can grow longer than great whites and live for centuries, yet it drifts so slowly in cold depths that sightings are rare. The megamouth shark was only discovered in 1976 when one was accidentally tangled in an anchor cable. Its gaping mouth, lined with glowing tissue, suggested a feeding style unlike any other large shark. Since then, only a few dozen have ever been documented, despite its size of up to 5 metres. If a shark that large could remain hidden until the late 20th century, how many others might still escape notice? Even whales, the most iconic giants of the sea, still carry mysteries. Blue whales are the largest animals to have ever lived, yet their migrations are not fully mapped, their populations not fully counted. Beaked whales, elusive relatives of dolphins, dive deeper than almost any mammal, sometimes staying submerged for over an hour. Many species of them have only recently been described, known before only from stranded carcasses. Some beaked whales may have entire populations that no human has ever observed alive, existing silently in the deep, surfacing only occasionally in remote waters. Their size does not protect them from mystery, it amplifies it, because we expect to see them, and yet we do not. Part of the reason giants slip away is that they live in realms we seldom visit. Many large squid inhabit the mesopelagic and bathypelagic zones, hundreds to thousands of meters down, where human presence is fleeting. Sharks like the Greenland sleeper drift in cold Arctic waters, inaccessible most of the year. Beaked whales prefer offshore trenches and deep canyons, far from coastal observers. Their habitats are vast, remote, and difficult to access. Even when we try, the chance of encountering a single individual in the immensity of the sea is small. It is like searching for a single elephant in the Sahara, only harder. because the elephant is moving in 3 dimensions and can vanish into darkness at will. Another factor is behaviour. Many of these giants are solitary or live in small groups. Unlike sardines that school by the millions, or dolphins that leap and play in pods, giant squids or beaked whales spend much of their time alone, minimising encounters. Some are slow-moving, conserving energy in nutrient-poor environments. Others are deep divers, surfacing only briefly to breathe before plunging again. By the time a ship crosses their path, they may already be gone, sinking silently below. Their very habits are designed for invisibility, whether intentional or simply evolutionary. Technology helps, but only slightly. Acoustic monitoring can detect whale calls, hinting at presence. Deep-sea cameras baited with food can attract squids or sharks, recording fleeting appearances. Satellite tags reveal migration routes when attached to whales or large fish. Yet each method has limitations. Acoustic data may not identify species precisely. Cameras cover small areas and may alter behaviour. Tags require capturing individuals, which is difficult for elusive giants. The result is that our knowledge, even with advanced tools, is patchwork. We know enough to confirm existence, but not enough to understand fully. And the stories of discovery reinforce this. The megamouth shark remained unknown until an accidental entanglement. The colossal squid came to light only through chance captures by fishing vessels. New species of beaked whale have been described from carcasses washed ashore. These giants do not reveal themselves willingly. They appear by accident, as if slipping momentarily out of shadow before vanishing again. Each reveal is reluctant, incomplete, and rare. This elusiveness shapes human imagination. We speak of cryptids, legendary creatures like the sea serpent or the kraken, as if they belong to myth. But the truth is that real giants, equally strange, already exist, simply unseen. The line between myth and reality is thinner in the ocean than on land. When people describe immense shadows moving beneath boats, it may not be fantasy. It may be glimpses of species we barely know. The giants of the deep are not imaginary. They are poorly documented realities, concealed by scale and secrecy. Even those giants we do know are mysterious in their details. The blue whale, despite its size, was once nearly driven to extinction by hunting, and its recovery is still uncertain. We do not know how many remain, where all of them migrate, or how climate change will affect their future. The sperm whale, famous for diving deep to battle squid, still carries unknowns in its behaviour, communication, and population dynamics. These are not marginal mysteries. They are central questions about animals we depend on as indicators of ocean health. The fact that even the largest animals evade full understanding shows how incomplete our picture remains, and perhaps that is part of the ocean's design. Size does not guarantee visibility. Giants can be as hidden as microbes, each for different reasons. Small creatures vanish because they are delicate, abundant, and overlooked. Giants vanish because they are rare, mobile, and inhabit places we cannot reach. Both extremes resist our gaze, reminding us that knowledge does not scale with size. The biggest shadows can be just as unknown as the tiniest specks. The ocean's giants also remind us how much more there is to learn about ecosystems as a whole. If we do not fully know the predators, how can we fully know the prey? If we cannot count the whales, how can we measure the plankton that sustain them? Each missing piece ripples outward. The absence of knowledge about giants is not just an absence of spectacle, it is an absence of ecological understanding. These creatures shape food webs, cycle nutrients, and influence habitats. Their mysteries are not trivial, they matter deeply. And so, the gigantic shadows that slip away leave us both humbled and restless. Every scar on a whale's head hints at battles with unseen squid. Every carcass on a beach hints at populations offshore. Every rare video of a colossal squid or a megamouth shark hints at entire worlds we've never watched. The giants remind us that the ocean is not empty, but filled with presences too large and too hidden for us to fully grasp. They prepare us to recognise that the unknown is not just an absence of detail, but a vast dimension of presence we cannot yet measure. And from there, the thread leads naturally onward, because if even the giants slip away despite their size, then what chance do we have with the creatures of the Midnight Zone, the ones who thrive in perpetual darkness where vision fails completely? Their world is not one of size, but of secrecy, and to enter it is to step into an environment that refuses to reveal itself except in flashes and fragments. For as long as people have tried to enter the ocean's deeper layers, the struggle has been as much about us as it has been about the creatures we hope to see. The barriers of darkness, pressure, and vastness do not only shape the animals who live there, they also shape our tools. We send down nets, cameras, submarines, and probes, but each carries limitations. Each is fragile in ways that the sea exploits relentlessly. For every advance in technology, the ocean responds with indifference, reminding us that our inventions are temporary guests in a place that has been harsh for millions of years. The fragility of our tools is one of the central reasons why so many ocean creatures remain unknown. The simplest devices we've used are nets. They seem straightforward. Drop a net, haul it up, study what comes inside. But in practice, nets are crude. The animals of the deep are often gelatinous, transparent, or delicate. When pulled into nets, they are torn apart, compressed, or destroyed entirely. What reaches the deck is sometimes little more than fragments, slimy masses that once were complex forms. Scientists do their best to reconstruct, but much is lost. Some species may have been caught hundreds of times without being recognised, simply because the bodies disintegrated beyond recognition. Nets, built for resilience against water and currents, are too harsh for the fragile beings they seek to capture. Even when nets succeed, they distort reality. They collect animals indiscriminately, mixing together creatures from different depths, smashing fragile ones against sturdy ones, and giving a false picture of who lives where. A net sample may contain hundreds of organisms, but without knowing their original positions in the water column, much of the ecological meaning is lost. The method is destructive, imprecise, and biased toward the tougher species that survive the journey. The most delicate animals, the very ones most likely to represent new discoveries, often vanish before they can be catalogued. To overcome these limits, scientists turn to submersibles. The idea of descending in a protected capsule seemed revolutionary, sending humans down to see with their own eyes. And indeed, submersibles have produced some of the most iconic images of the deep sea. But they are rare, expensive, and limited. Building a vessel strong enough to withstand pressure requires heavy hulls, usually spherical to distribute force. That design constrains size and maneuverability. Submersibles can stay down only as long as their oxygen and power last, often just a few hours. Every dive is costly, requiring ships, crews, and careful planning. The result is that human presence in the abyss is still counted in days and hours, not in years or decades. Our tools are too fragile for permanence. Cameras too have their issues. To film in the dark you need lights, but lights alter behaviour. Some animals flee from illumination, others are drawn unnaturally. Still others behave in ways that are not representative. What we record may not be reality, but a distortion created by our intrusion. In recent years, scientists have experimented with low-light cameras that can record bioluminescence without artificial beams, but these are still limited in range and sensitivity. For every glowing squid or fish captured on film, countless others remain outside the narrow frame. Cameras, no matter how advanced, are fragile against the vastness, able to record only fragments of the whole. Then there are remotely operated vehicles tethered to ships above, carrying manipulators and sensors. These have given us remarkable views of vents, trenches, and mid-water animals, but their tethers are vulnerable. Strong currents can drag them, cables can snag, and communication delays make fine manoeuvring difficult. Autonomous vehicles remove the tether but carry their own risks. They operate without real-time guidance, so they may miss important encounters or even be lost entirely. Each mission involves risk, cost, and fragility. For every successful deployment, there are failures, malfunctions, or recoveries that reveal damaged equipment. The ocean is not kind to machines. Even the most advanced instruments, like deep-sea landers equipped with cameras and bait, face limitations. They can film for hours or days, but only within the range of their lens. They attract scavengers and predators, but not the full spectrum of life. The bait biases results towards certain species, leaving others invisible. And when the time comes to retrieve them, there is always the chance that something goes wrong, that the signal is lost, that the machine never resurfaces, that storms interfere. Each deployment is a gamble. Fragility also shows in data. Sensors that measure temperature, salinity, or chemical composition are prone to drift, corrosion, or clogging. Delicate instruments fail under pressure, or biofouling organisms colonize them, altering readings. Long-term monitoring is difficult when every piece of equipment is fighting against salt water, currents, and pressure. Even satellites, which provide global views of surface conditions, can only infer what lies beneath. They measure colour, height, or surface temperature, but the life below remains concealed. The deeper you go, the less reliable our tools become. This fragility has a cost beyond lost data. It discourages exploration. When instruments cost millions and risk failure on every dive, expeditions become rare. Scientists must fight for limited funding, plan carefully, and often settle for partial answers. The unknown persists not because of lack of curiosity, but because our machines cannot endure the harshness long enough to make curiosity productive. The ocean punishes fragility, and our tools remain fragile. And it's not just machines. Human bodies are fragile too. Divers cannot descend beyond a few hundred meters without facing fatal risks. Even with advanced equipment, saturation divers who work at oil rigs are confined to depths far shallower than the abyss. Beyond that, only machines can go. Our own biology is unsuited to the deep, and no amount of training can change that. We are surface creatures, peering into a fortress with borrowed tools that are always at risk of breaking. What this means for discovery is sobering. Many ocean creatures remain unknown, not because they are rare, but because our methods are too blunt, our machines too delicate, our reach too short. A fragile jelly destroyed in a net, a squid frightened away by lights, a fish missed by a camera's narrow frame. Each is an absence, a missed chance, a mystery preserved. Multiply that by millions, and you begin to see why the catalogue of life remains incomplete. Yet fragility is not only a weakness, it has also driven innovation. The constant failures force engineers to build better machines, scientists to invent gentler methods, and explorers to adapt. Pressure-resistant tanks now keep some deep-sea animals alive at surface conditions. Low-disturbance samplers collect fragile jellies without destroying them. Acoustic monitoring provides new ways of detecting presence without light. Fragility is a barrier, but it is also a teacher, pushing us to refine how we look and listen. The process is slow, but it expands possibility. Still, the lesson remains clear. The ocean is harsh, and our tools are too fragile for full mastery. We will always be limited by cost, durability, and reach. There will always be creatures we cannot collect, signals we cannot interpret, habitats we cannot access. Fragility ensures that mystery will not vanish, that the unknown will persist. For every machine we send, for every sample we take, there will be countless lives still untouched, still hidden by the sea's refusal to accommodate our instruments, and this prepares us for the next realization. Fragility is not only mechanical, it is conceptual. Even when we manage to capture or record creatures, our ability to name, classify and understand them lags behind. The backlog of samples, the slowness of description, the challenge of fitting new forms into existing systems. All of these mean that even when the ocean does reveal, the knowledge often waits years before it becomes official. The tools of science itself, fragile in their own way, add to the delay. Most of the time, the ocean gives us fragments: a torn tentacle hauled up in a fishing net, a blur on a low-light camera, a carcass washed onto a remote beach. These are the usual ways we come to know its creatures, not through full encounters, but through pieces, reminders that life exists just beyond reach. Yet every so often, the sea grants something different, a glimpse so complete, so undeniable, that it transforms what we thought we knew. These rare moments are not just sightings, they are revelations. They change everything, not only because they add new knowledge, but because they alter our sense of possibility. One of the most famous examples is the giant squid. For centuries, it was the stuff of sailors' tales and fearful sketches. It left traces, tentacles, beaks, scars on sperm whales, but never appeared alive. It was easy to dismiss as myth. Then, in the early 21st century, cameras finally captured one in its natural habitat. There it was, drifting with long arms trailing, massive and graceful. Not a monster but an animal, alien and real. That single recording shifted perception. What was once legend became fact. Entire narratives about sea monsters were reframed as distorted reports of a real creature. The glimpse changed everything, not just for science, but for culture. Another example comes from hydrothermal vents. Before the 1970s, scientists assumed the deep ocean was mostly barren, at least when it came to complex ecosystems. Then a submersible descended along the Galapagos Rift and found chimneys spewing mineral-rich water surrounded by life. Giant tube worms, clams, crabs, fish, all thriving without sunlight, sustained by chemosynthetic bacteria. That glimpse shattered assumptions about what life needed. Suddenly it was clear that ecosystems could exist without the sun, fueled instead by the Earth's chemistry. That discovery reshaped biology, and even astrobiology. If life could thrive in the dark on Earth, perhaps it could thrive in subsurface oceans elsewhere in the solar system. The glimpse widened our sense of where life might exist in the universe. Sometimes, glimpses come not from direct observation, but from the unintended consequences of technology. In the mid-20th century, sonar operators began detecting a mysterious, deep, scattering layer, a band of echoes that rose at night and sank during the day. At first, it was thought to be the seafloor itself shifting oddly. But it was later revealed to be billions of fish and plankton, migrating daily in what is now called the greatest animal movement on Earth. That glimpse came not from sight, but from sound, and it changed how we understood ocean life. What seemed empty was in fact crowded, moving constantly, hidden by darkness until technology exposed it indirectly. And sometimes, rare glimpses come in ways that feel almost accidental. The megamouth shark, one of the largest fish in the ocean, was unknown until 1976, when one became entangled in an anchor cable off Hawaii. Its enormous mouth lined with light-producing tissue suggested a feeding strategy unlike anything known. Since then, only a few dozen have been recorded, each one a rare encounter. Without that first accident, the species might still be unknown. The glimpse forced science to acknowledge that even massive creatures can remain hidden until chance brings them forward. The impact of these moments is not just scientific. They ripple into imagination. Each rare glimpse reminds us that the ocean is not static but alive with surprises. It humbles assumptions, forces us to reconsider boundaries, and often raises more questions than it answers. When a Dumbo octopus was first filmed flapping its ear-like fins in the abyss, it captivated audiences worldwide. Not because it solved a mystery, but because it revealed strangeness we hadn't expected. When deep-sea jellyfish display pulsing lights caught by submersibles, they remind us that beauty thrives in places we once called lifeless. Each glimpse alters not only knowledge but emotion. What makes these glimpses powerful is their rarity. They are not routine. They cannot be scheduled. They arrive unpredictably, sometimes after years of effort, sometimes entirely by accident. And because they are rare, they carry weight. Scientists spend careers chasing them, hoping for a moment when the ocean reveals something new. The footage of the giant squid required patience, specialized equipment, and luck. The discovery of hydrothermal vents came from following a hunch. The megamouth shark appeared without warning. None of these could have been planned perfectly. The ocean does not perform on command. It reveals reluctantly, and only in moments it allows. That reluctance means we cannot build knowledge the way we do in other fields. In a laboratory, experiments can be repeated. On land, animals can be observed continuously. In the ocean, discoveries often depend on waiting for glimpses, which may not repeat for decades. That makes the unknown persistent. Even after one sighting, questions linger. How many giant squid are there? How do they live? How often do they breed? A glimpse answers one question and generates dozens more. Knowledge grows unevenly, in bursts, leaving gaps all around. This unevenness explains why so many ocean creatures remain undocumented. We have seen them briefly, but not fully. We know they exist, but not enough to classify or understand them. There are records of strange fish caught once and never again, jellies filmed fleetingly and never relocated, noises recorded but never matched to bodies. Each is a glimpse, tantalizing and incomplete. Each suggests whole lineages still hidden. The ocean does not deny us entirely. It offers samples, fragments, sightings. But the bulk remains concealed, just beyond repetition, just beyond systematic study. And when glimpses do come, they sometimes overturn entire fields. Before the first vent communities were found, textbooks declared sunlight essential to ecosystems. Before the first megamouth shark, no one imagined filter feeding in such a form among sharks. Before the first recordings of giant squid, myths filled the space of fact. Each revelation forces rewriting, not just filling in blanks, but erasing assumptions. The rare glimpses do not just add, they change frameworks. They remind us that what we think we know may be built on absence. They also highlight the importance of patience. Science often celebrates continuous monitoring, but in the ocean, patience is more powerful. Hours of silence, days of emptiness, then suddenly, something extraordinary. Submersibles sit for long stretches recording nothing, until an animal drifts into view. Hydrophones record static until an unknown sound pulses through. The waiting is part of the process, because the ocean reveals only when it chooses. Patience is rewarded not with abundance, but with singularity. And that singularity can alter everything. For those who study the deep, these glimpses are addictive. A single sighting fuels decades of work. A single discovery justifies years of investment. The image of a colossal squid's eye, the footage of a Dumbo octopus, the unexpected recording of a new whale song, each becomes iconic, replayed, shared, discussed endlessly. They serve as anchors of knowledge in a sea of mystery. They are not common, but they are enough to remind us that discovery is possible. They keep exploration alive. But there is another layer to this. Rare glimpses remind us how fragile knowledge is. A giant squid filmed once does not mean we understand it. A hydrothermal vent community mapped once does not mean we know them all. Without repetition, without continuous study, knowledge risks fading again into uncertainty. That is why so many ocean creatures remain unknown even after glimpses. We see them, but only briefly. Then they vanish again, swallowed by the vastness. It is tempting to think of these glimpses as gifts, moments when the sea allows us to peek. But perhaps they are not gifts at all. Perhaps they are simply accidents, times when our path crosses with the hidden. Either way, they shape our relationship with the ocean. They remind us that the unknown is not theoretical. It is real, documented, undeniable, and still immense. The rare glimpses that change everything are proof that the unknown is alive and waiting. And as we follow that thought, we begin to see the next barrier. Because while glimpses reveal what exists, they also remind us of everything we cannot yet classify. For every creature filmed, dozens of samples sit unnamed in collections. For every sound recorded, dozens remain unassigned. The slowness of science, combined with the backlog of material, ensures that even when the ocean does reveal, the process of turning glimpses into knowledge lags far behind. Long before submersibles and sonar, before cameras and nets capable of reaching the deep, people still encountered the ocean daily. They sailed across it, fished its shallows, watched storms break against its waves. And in those interactions, they saw things that defied explanation. Strange shapes beneath the water, enormous carcasses washed up on beaches, mysterious sounds echoing through the hulls of ships. These fragments were all they had, and fragments demand interpretation. Without science to provide structure, myths arose to fill the gaps. The unknown was not left blank, it was filled with stories. Myths flourished around the ocean because it is vast, dangerous, and only partially visible. A sailor staring into endless water sees shadows move beneath the surface. A storm lifts waves higher than any building, making the sea feel alive, hostile, and animated by forces beyond comprehension. In such settings, it is natural to imagine beings responsible for what is seen and felt. The kraken, the leviathan, sea serpents, mermaids, all of these emerge not from empty imagination, but from encounters with a world that revealed little and concealed much. Myths were attempts to explain a reality that science could not yet access. Consider the kraken, described in Scandinavian tales as a creature so massive it could drag ships into the deep. Sailors reported seeing enormous arms and whirlpools forming where the beast descended. For centuries this was dismissed as fantasy, but we now know that giant squid exist, with arms stretching more than 10 meters, and that sperm whales bear scars from battling them. To a sailor in the 15th century, catching a glimpse of a squid's tentacle or witnessing a struggling whale might easily transform into a story of a monster. The lack of repeatable evidence meant myth took root. What was real was hidden enough that imagination filled the space. Leviathan, mentioned in ancient texts, often symbolized chaos and fearsome power. Descriptions varied, sometimes as serpent, sometimes as sea dragon, sometimes as a force of the deep itself. In regions where whales were unfamiliar, the sudden breach of a massive animal could be interpreted as monstrous. To early observers, there was no distinction between myth and reality. Both were attempts at sense-making. Leviathan endured not because it was false, but because it captured the immensity and unpredictability of the sea. The myth flourished because science had not yet touched those waters. Mermaids are another example. Reports of half-human, half-fish beings appear in cultures around the world, from Europe to Africa to Asia. Some of these likely arose from sightings of manatees or dugongs, animals that from a distance might resemble a human-like figure surfacing with rounded bodies and forelimbs. Others may have been symbolic, reflecting cultural ideas of liminality, the boundary between land and sea personified. Either way, they show how the unknown ocean invited anthropomorphic projections. The creatures of myth were not random. They were products of glimpses, distance, and imagination, applied where knowledge could not yet reach. Even sounds became sources of myth. Sailors described groans and moans rising from the depths, strange noises that seemed too deliberate to be natural. Without hydrophones or understanding of whale songs, these were attributed to sea monsters or spirits. The ocean amplified sound in ways unfamiliar to those used to air. What was a whale called to us now was once a voice of the unknown. Myths thrived in those misunderstandings. They gave names and shapes to experiences that felt too powerful to remain undefined. One reason myths endured so strongly is that they offered coherence. The sea was unpredictable, threatening storms, wrecks, and famine. By imagining monsters, people could assign agency to disaster. If a ship vanished, it was because the Kraken took it. If storms struck, it was the anger of gods. If strange carcasses appeared, they were remains of Leviathan. Myth gave structure to chaos, comfort in narrative where randomness would have been unbearable. Science had no tools yet, so myth filled the role of explanation, even if imperfectly. Another reason was that myth travelled well. Stories spread faster than specimens. A whale carcass might wash ashore only in one village, but the story of it could travel across continents, gaining embellishments each time. A glimpse of a strange fish in one sea became the foundation for tales of sea serpents across many. Without photographs or preserved samples, stories were the primary currency of ocean knowledge, and stories evolve, adapting to cultural fears and desires. The ocean provided raw material, and myth sculpted it into lasting forms. Even when science began to explore more systematically, myths persisted. Early naturalists often struggled to distinguish fact from folklore. Reports of giant fish, monstrous squids, and glowing creatures were sometimes dismissed, sometimes catalogued as real. In the absence of repeated evidence, the boundary between myth and science blurred. Some animals, like the giant squid, straddled both categories for centuries. Others, like the oarfish, became partial explanations for myths. Long, ribbon-like bodies surfacing occasionally, interpreted as sea serpents. Myth flourished because reality was still too fragmented to contradict it fully. In this way, myths were not failures of understanding. They were provisional knowledge, the best explanations available at the time. They reflected genuine encounters with unknown creatures, filtered through imagination and storytelling. In some cases, myth preserved truths before science could verify them. The Kraken was myth, but also a distorted memory of squid. Leviathan was symbol, but also an echo of whales. Sea serpents were fiction, but also fragments of oarfish sightings. Myth held space for realities we had not yet uncovered. And myths continue even today. Despite our advances, the unknown ocean still inspires speculation. Mysterious sounds like the bloop in the 1990s sparked rumours of giant undiscovered animals before being linked to ice quakes. Strange footage online still circulates, labelled as proof of monsters. Fictional depictions in film and literature draw on the same traditions, creatures of immense size lurking unseen. The endurance of these myths shows that the conditions that created them remain: vastness, rarity, secrecy. As long as the ocean hides more than it reveals, myth will flourish alongside science. What's important is that myths often point toward the very reasons creatures remain unknown. They arise in the gaps between what is seen and what can be explained. They flourish when tools are too fragile, when glimpses are too rare, when environments are too hostile. In that sense, myth and science are not opposites, but stages in the same process. Myth occupies the unknown until science arrives. And even when science does arrive, myth lingers, shaping how we interpret discoveries. The flourishing of myth where science could not reach also teaches humility. It reminds us that our current knowledge, though vast compared to the past, may itself be provisional. Today, we dismiss some stories as fanciful, but future discoveries may validate fragments of them. Just as squid emerge from the Kraken, future creatures may emerge from the shadows of today's speculations. The unknown is fertile ground, and myth will always sprout where evidence is thin. And this leads naturally to the next recognition. Myths may flourish when the unknown is total, but patience sustains mystery even when glimpses occur. The ocean's secrets do not vanish after discovery. They persist, guarded by slowness, distance, and resistance. Just as myths linger, so too does mystery, nurtured by the endless patience of the sea itself. If there is one quality the ocean possesses in abundance, it is patience. Its currents move on scales of centuries, its trenches have existed for millions of years, Its cycles of life and death unfold with a slowness we rarely witness on land. Against that backdrop, human exploration is frantic and brief. Our expeditions last days, our instruments fail after months, our careers span only decades. The ocean has no reason to reveal itself quickly. Its secrets wait, unchanging in their rhythms, indifferent to our urgency. This endless patience is another reason why so much of marine life remains unknown. We measure progress in terms of discoveries per year, papers published, species described, but the ocean operates on different scales. A whale carcass might sink and support an ecosystem for decades, unseen by us. A deep-sea coral might grow millimetre by millimetre for centuries before reaching its full form. A trench-dwelling fish may reproduce slowly, producing only a few offspring in its long lifespan. These are not lives or events that reveal themselves in quick bursts. They require patience equal to their own, and humans are rarely able to sustain that. We visit briefly, take samples, and leave. The ocean continues without us, waiting silently for the next attempt. The patience of the ocean is evident in how it conceals. Consider the daily migration of billions of small fish and plankton, rising at night and sinking during the day. This has been happening for countless millennia, one of the largest movements of biomass on the planet. Yet we only discovered it in the 20th century because we lacked the tools to notice. The migration was not hidden intentionally. It was happening all along, patiently repeating itself, whether or not anyone was there to observe. It was our lack of patience, our short perspective, that delayed discovery. Hydrothermal vents tell a similar story. They existed long before we found them, releasing minerals and hosting thriving communities. The ocean did not hide them in malice, it simply waited. Until we built submersibles capable of descending to ridges, the vents were inaccessible. When we finally arrived, they were there as they had always been, indifferent to whether humans had ever imagined them. That is the nature of the ocean's patience. It reveals nothing on our schedule, only on its own. The slowness of deep sea life reinforces this patience. Many species live at such low metabolic rates that growth and reproduction take extraordinary amounts of time. Orange ruffy, a deep-sea fish, can live more than a century. Some corals grow for thousands of years, their skeletons holding records of climate change across millennia. For these creatures, time is stretched, and discovery is unlikely within a single human lifetime. If you study a coral colony for 30 years, you may only see a fraction of its existence. If you observe a fish for a decade, you may witness only a handful of its reproductive events. The patience required to truly know these species exceeds what most humans can sustain. Even when we do encounter something new, the ocean ensures that mystery persists. A rare video of a squid does not explain its life cycle. A specimen hauled up does not reveal its behaviours in the wild. A sound recorded once does not unlock a species' communication. Each clue is partial, and piecing them together requires not just effort but time. The backlog of samples in museums is proof of this. Jars of unidentified plankton, fish and invertebrates sit for decades waiting for someone to examine them. Our pace cannot match the patience of the sea. We want answers quickly, but the ocean offers them only slowly, one fragment at a time. This slowness explains why myths and mysteries endure even in the modern age. We have satellites that can scan the surface of Mars in detail, yet vast swathes of our own seafloor remain unmapped. We build telescopes to peer billions of light years into the past, yet we cannot continuously observe the daily lives of animals only a few kilometres below. The patience of the ocean ensures that knowledge will always lag behind curiosity. It is not that we lack ability entirely. It is that the scale of patience required is beyond what our societies are built to support. In a way, this patience also protects the ocean. Rapid exploitation is difficult in places where life grows slowly and environments resist quick access. Fisheries that target deep-sea species often collapse quickly because the animals reproduce too slowly to recover. Mining proposals for seafloor minerals face uncertainty because ecosystems take centuries to establish. The patience of the sea becomes a defense mechanism, not by intention, but by structure. Its secrets cannot be harvested quickly because they are not produced quickly. The endless patience is humbling, but it also highlights why discovery feels so dramatic when it happens. A new species described is not just a name on a list. It is a breach in the ocean's long silence, a moment when patience yields to presence. The rarity of such events makes them precious. They remind us that knowledge is possible, but not on demand. They remind us that the ocean operates on scales that dwarf us, and that to truly know it requires humility. This patience also shapes how creatures themselves behave. Many animals in the deep live slow lives, conserving energy in scarcity. They drift rather than chase, ambush rather than pursue, reproduce rarely rather than often. Each adaptation reflects an acceptance of slowness. The ocean's secrets are not dramatic in their unfolding. They are gradual, measured, drawn out over centuries. To study them, we must learn to adopt some of that patience ourselves, resisting the urge to rush. And perhaps that is the most difficult lesson. Human curiosity thrives on immediacy. We want to know now, to solve mysteries quickly, to move on. The ocean resists that impulse. It forces us to wait, to accept partial knowledge, to live with uncertainty. Its patience is endless, and ours is not. That mismatch ensures that most of its creatures will remain unknown for a long time yet. Even with better technology, better sampling, better analysis, the scale of waiting will always exceed us. But patience is not emptiness. It is fullness stretched across time. The secrets of the ocean are not absent. They are present, waiting, enduring. Each one sits beneath the surface, unchanged by our timelines, ready to be glimpsed eventually. The patience of the sea means that discovery is never final, that mystery always persists, that the unknown will always outlast us. And from here, the thought leads naturally onward. Because if the ocean has infinite patience, then each encounter we do manage to have, each face-to-face meeting with the unknown becomes even more significant. The patience makes the moments of revelation stand out all the more, reminding us how rare and fragile they are. When humans meet the unknown in the deep, it is not just exploration. It is a negotiation with patience itself. When humans descend into the ocean, either within small submersibles or through remote vehicles operated from ships, the encounters they have are unlike anything else in exploration. In space, we look outward from a distance, always separate from the worlds we study. On land, we observe animals directly, often over extended periods. In the deep sea, though, when a human finally comes face to face with an unknown creature, the moment is charged with something different, an intensity that comes from rarity, fragility, and the recognition that the meeting may never be repeated. These are moments that live long in memory, not only for the scientists involved, but for the rest of us who hear about them later. The first time many people saw footage of a Dumbo octopus floating through the black, flapping its ear-like fins as if swimming in slow motion, it didn't feel like watching an animal so much as watching a dream. Its gentle movements and strange shape seemed almost theatrical, as though it were aware of being observed. But for the researchers who filmed it, the encounter was far more practical and profound at the same time. It was the confirmation that life at those depths was not only surviving but thriving in unique, delicate ways. That single moment of contact between machine, human, and octopus became a story replayed around the world. The animal had always been there, drifting unseen. Only in that instant did it meet us face to face. There are many other such moments, each marked by the same mixture of astonishment and humility. A pilot in a submersible watches as a transparent fish swims past, its skull translucent, its eyes like green domes aimed upward. For years, that fish, called the barreleye, was known only from dead, damaged specimens brought up by nets, where the eyes collapsed and the body lost its form. Seeing it alive revealed not only how it looked, but how it behaved, holding steady in place with precision, rotating its eyes within its head to track movement above. That encounter turned a grotesque curiosity from museum jars into a living, graceful presence. Meeting it face to face transformed the idea of what that fish was. Sometimes the encounters are dramatic. Submersibles have filmed sharks larger than the craft itself swimming by in silence, their eyes briefly catching the reflection of lights before fading again into the dark. In those moments, humans become the smaller, more fragile presence, confronted by giants who live at ease in conditions that would kill us in seconds. The face-to-face meeting is humbling, a reminder that size and power in the ocean belong not to us but to them. Even when no aggression occurs, the imbalance of scale is unforgettable. Other times the meetings are subtle, a jellyfish drifting in place, pulsing rhythmically, bioluminescence flickering across its body like faint signals. The human eye catches it only because of the light, yet the jellyfish is unaware or indifferent, living its life as it has for millions of years. To meet such an animal is to confront a form of existence so different from our own that communication is impossible. There is no recognition, no shared gaze, only the one-sided awareness of us observing it. And yet even that one-sidedness feels powerful. It is the first time we see the creature alive, in its own environment, undisturbed by nets or captivity. The face-to-face meeting is real, even if unreciprocated. For the scientists inside submersibles, these encounters often create conflicts between instinct and protocol. The instinct is to marvel, to let the moment stretch, to absorb every detail. The protocol is to record data, measure, and move on. In the end, most choose both, filming carefully while quietly acknowledging the significance of being present. Every hour in the deep is expensive, every observation must be justified, but the human experience of meeting the unknown face-to-face transcends cost. Those who return from dives often describe not just data collected, but emotions felt, the way the encounters altered their sense of scale and mystery. Encounters also carry risk, not of attack, but of fragility. A remotely operated vehicle once filmed a jellyfish so delicate that even the turbulence of its propellers nearly tore it apart. To meet such creatures is to recognize how easily our presence could erase them. The face-to-face moment becomes not only awe-inspiring but precarious. We realize that our tools are blunt, our methods disruptive, and the creatures we seek are often too fragile to endure contact. The ocean allows us glimpses, but it also warns us not to linger too roughly. In some cases, encounters are accidental. A camera lowered to film seafloor geology captures instead a strange fish never described before. A baited lander meant for crabs records a new species of snailfish. These face-to-face meetings happen not because we aimed for them, but because the creatures chose, in their own rhythms, to approach. It reminds us that exploration is not entirely under our control. We may prepare meticulously, but in the end, the creatures decide whether the meeting occurs. That unpredictability is part of why these moments feel so charged. There is also a unique quality to knowing that you may be the first human ever to see a particular animal alive. On land, that possibility is rare. Most animals have been seen by someone at some time. In the deep sea, it is common. Scientists in submersibles often remark that every dive reveals creatures unknown to science. To meet them face to face is to cross a threshold. An animal that has existed for millennia is suddenly documented, named, and recognized by humans. The significance of that act cannot be overstated. It is not conquest, but acknowledgement. The creature becomes part of shared knowledge. But the face-to-face meeting also underscores our limitations. To see is not to understand. Many of the animals filmed remain unnamed, their biology undescribed, their ecology unstudied. A video clip shows movement, shape, perhaps light, but it does not reveal reproduction, diet, or lifespan. The meeting is brief and incomplete. We meet the unknown, but we do not tame it. Instead, we add another layer of mystery, a new question for every answer. For the public, these encounters are transformative too. When footage of a rare deep-sea animal is released, it spreads widely. People watch in wonder, marveling at forms so alien they seem fictional. Each meeting becomes a cultural event, proof that the ocean still holds surprises. In this way, the scientists' face-to-face meetings ripple outward, shaping imagination and reminding everyone that the world is not fully known. The collective sense of mystery grows, sustained by these rare fragments. Yet for every face-to-face meeting recorded, countless others go unrecorded. Submersibles may pass near creatures just outside their lights. Cameras may miss encounters by meters. The unknown may have been present but unseen. That knowledge is humbling. It reminds us that the meetings we celebrate are not comprehensive. They are accidents of overlap, moments when our fragile tools happen to intersect with a creature's path. Most of the time the paths diverge, and the creatures continue unseen, and that is what keeps the sense of mystery alive. The face-to-face moments are precious precisely because they are rare. They do not end the unknown, they deepen it. Each meeting suggests countless others we have not had. Each glimpse proves that discovery is possible but incomplete. The unknown is not diminished by meeting it. It is expanded, because every presence implies absences still waiting. From this awareness, the story naturally turns toward what comes after such meetings. Once the unknown has been glimpsed, samples collected, footage shared, the task falls to the slow machinery of science. Naming, classifying, describing, analysing. These processes take years, and often they struggle to keep pace with the rare encounters that reveal new creatures. The backlog grows, and the gap between discovery and understanding widens. The face-to-face meetings are extraordinary, but they are only the beginning of a long, slow process that ensures the ocean's mysteries remain vast for generations. When people think of ocean life, it often feels separate, distant, as if the creatures drifting in the depths belong to another world entirely. But the truth is that we are more connected to them than we might realise. These connections are not always visible or direct. They are hidden in cycles of air and water, in the chemistry of the planet, in the long arcs of evolution that shaped all living things. To say that ocean creatures are unknown to us is not only to say that they remain unseen in their own realm, is also to say that we have not fully grasped how deeply tied we are to them, how our lives and theirs are interwoven across invisible lines. Start with the most basic connection, the air we breathe. Much of the oxygen on Earth is produced not by forests or grasslands, but by phytoplankton, microscopic plants drifting near the surface of the sea. These tiny lives, almost invisible to the eye, shape the atmosphere itself. Every second breath you take carries oxygen that began in their bodies. They live far from human cities, and yet every human depends on them. The connection is constant, silent, hidden, but essential. Without them, life on land would collapse. They are unknown in the sense that few people ever see them, but they are intimate in the sense that every breath reminds us of their presence. Then consider the cycles of carbon. Oceans act as enormous carbon sinks, absorbing vast amounts of carbon dioxide from the air. Plankton fix it into their tissues, fish consume it, and eventually much of it sinks into the deep, stored for centuries or longer. This slow circulation regulates climate, shaping the very conditions in which human civilization can thrive. When plankton communities shift, the balance shifts. When deep-sea ecosystems are disrupted, carbon cycles are disrupted too. The hidden connection is planetary. What happens in the deep affects weather, agriculture, economies, and survival far above. We are linked not by choice but by chemistry. The food we eat provides another connection. Fisheries depend on complex food webs that begin with plankton and extend upward through small fish, larger predators, and finally to the species humans harvest. A single disruption at the base, a decline in plankton due to warming seas for example, ripples upward until entire fisheries collapse. Communities on land that may never see the deep sea nonetheless rely on its invisible productivity. A hidden connection stretches from the unseen lives in the depths to the meals on human tables, but the connections go beyond resources. They reach into the history of life itself. The ancestors of land animals emerged from the sea hundreds of millions of years ago. Our lineage is marked by adaptations first honed in the water. Bones, jaws, lungs, even the arrangement of our senses trace back to ocean creatures. Evolution carries these connections forward. We are not separate from them in origin. We are their descendants, reshaped by land but still carrying echoes of their designs. Our bodies hold traces of ocean chemistry, salty blood, mineralized skeletons that remind us of shared ancestry. To study them is, in a way, to study forgotten parts of ourselves. Even myths reflect these hidden ties. When ancient people imagined sea monsters, mermaids, or leviathans, they were expressing both fear of the unknown and recognition of kinship. The creatures were different, yes, but also similar enough to be anthropomorphized given human features, motives, and roles. The myths were projections of ourselves into the water, a reminder that we sense connection even when we cannot articulate it. That instinct to connect has persisted, and modern stories, films, literature, speculation about alien oceans continue to mirror the idea that what lives in the sea is not wholly other, but somehow bound to us. There are also direct encounters that show the connection. Divers in shallow seas often describe being studied by curious fish, dolphins, or even large squid. The creatures are not indifferent. They respond, approach, and sometimes initiate interaction. These moments reveal that the boundary between us and them is not impenetrable. There is awareness on both sides. To look into the eye of a whale or an octopus is to recognize intelligence, curiosity, and presence that feels familiar. The hidden connection becomes visible for a moment, then fades again into mystery. But perhaps the most powerful connections are those that remain unseen. Unknown creatures in the deep are part of systems that sustain stability on Earth. They recycle nutrients, regulate gases, and provide resilience against change. Without them, life on land would falter. The fact that we do not see them, name them, or understand them does not make them less connected. It only makes the connection less recognized. Our ignorance does not cancel their importance. If anything, it makes it more urgent to acknowledge. These connections also run in the other direction. Our actions affect them. Plastic drifts into the sea, breaking down into microscopic particles that plankton ingest. Carbon emissions warm and acidify the water, stressing corals, plankton, and fish. Noise from ships interferes with whale communication. Fishing removes species faster than they can reproduce. The unknown creatures of the deep are not isolated. They are entangled in human influence. Even if we never meet them face to face, our choices ripple into their lives. The hidden connection is not only that we depend on them, but that they must endure us. And the depth of these ties extends beyond practical consequences. The ocean shapes imagination, art, and culture. Its mysteries inspire stories. Its creatures fuel curiosity. Its vastness provokes humility. Even people who never see the sea live in cultures shaped by its presence. The unknown creatures below are part of that influence, because their very mystery sustains the sense of wonder. In this way, the hidden connection is emotional and psychological, not just biological. They affect how we think about the world and our place in it. These connections complicate the idea of unknown. To say that most ocean creatures remain undiscovered is true in the sense of classification and observation. But in another sense, they're already present in our lives, shaping our air, climate, food, and imagination. They are not absent, they're integrated invisibly. The unknown is not somewhere else. It is here already, acting through hidden connections that sustain daily existence. And perhaps that realization is what prepares us for the next step. Once we acknowledge that the unknown is not separate but entangled with us, we begin to see that our future depends on them as much as theirs depends on us. The unknown is not just an intellectual puzzle to solve, it is a relationship to recognize, and that recognition opens the way to new kinds of questions, not only about what creatures remain unseen, but about what futures remain possible if we continue to ignore the connections that bind us. When we look into the ocean searching for what is unknown, we often say we are trying to learn about the animals that live there, or about the ecosystems that sustain them. That is true, but it is not the full picture. Each expedition, each rare glimpse, each fragile specimen does not only reveal something about them, it also reveals something about us. The search itself becomes a mirror. In trying to uncover the mysteries of the ocean, we confront the limits of our own curiosity, the fragility of our own tools, the persistence of our myths, and the scale of our patience. The process of searching shapes us as much as the discoveries do. One of the first lessons is humility. We are a species used to mastery. We build cities, transform landscapes, and even send machines to other planets. On land, it is easy to feel as though there are few mysteries left, but the ocean resists that feeling. It reminds us that we are not as powerful as we think. No matter how advanced our technology becomes, we remain clumsy guests in the deep, dependent on machines that break, lights that fail, and vessels that withstand only brief visits. Searching for the unknown reminds us of the limits of control. It humbles us, showing that most of the planet is beyond our direct reach. Another lesson is persistence. The ocean gives nothing easily. Discoveries often come after years of effort, after repeated failures, after endless patience. The search for the first live footage of a giant squid required decades of attempts before one brief success. The discovery of hydrothermal vents came after long expeditions and uncertainty. Scientists and explorers accept that the unknown will not yield on demand. That persistence, the willingness to endure failure for the chance of a single glimpse, reflects something about human character. It shows that our curiosity is strong enough to overcome difficulty, that we are willing to invest time and resources for knowledge even when reward is uncertain. The act of searching demonstrates persistence not only in science, but in the human spirit. The search also reveals our imagination. Before we capture images, before we describe species, we imagine them. Myths, legends, and speculative drawings fill the gaps long before cameras did. Even today, when we find new creatures, we compare them to stories, aliens, or characters. Our imagination does not simply wait for discovery. It anticipates it, shapes expectations, and influences how we interpret what we see. Searching the ocean shows us how much we rely on imagination, not as an alternative to science, but as a companion. It is imagination that sustains interest when the data is sparse, that drives expeditions when results are uncertain. In this way, searching them teaches us that imagination is not weakness. It is a core part of curiosity. The unknown ocean also reflects our impatience. On land, we expect answers quickly. In medicine, technology, or communication, solutions arrive fast. But in the ocean, progress is slow. It forces us to wait, to accept uncertainty, to live with fragments. Searching them reminds us that not all knowledge can be rushed. The discomfort we feel at that slowness tells us something about our expectations. We struggle to live with mystery, to tolerate the unknown, and yet, the ocean insists that mystery will always remain. Searching them reveals our impatience, but it also trains us to manage it, to stretch attention across longer spans than we're used to. We also learn about our tendency to see ourselves in others. When explorers describe looking into the eye of a whale or an octopus, they often speak of recognition, of sensing intelligence or awareness that feels familiar. That may be projection, but it also reflects a truth about us. We connect by seeing likeness. Searching them reveals not only differences but similarities, teaching us that kinship exists even across great evolutionary divides. The need to find ourselves in them shows our desire for connection, for continuity across life. It shows that part of searching is not only to catalogue but to relate, to see the world as filled with companions rather than strangers. Another lesson lies in how we value discovery. We celebrate rare glimpses, we share footage widely, we marvel at the strange. This reveals our hunger for wonder, even in an age when so much of daily life feels mapped and predictable. We crave reminders that the world is still larger than us. The excitement that spreads when a new deep-sea animal is filmed is not only about biology, it is about renewing the sense that mystery still exists. Searching them teaches us that we need the unknown, not only to expand science, but to sustain imagination and wonder in human life. The ocean also reflects our contradictions. We search eagerly, but we exploit carelessly. We marvel at whales, yet once hunted them to near extinction. We admire coral reefs, yet pollute and warm the waters that sustain them. Searching them reveals this conflict. It forces us to confront the gap between curiosity and responsibility. Do we value them only as curiosities, or do we also value their survival? Searching the unknown ocean highlights this question, and in doing so, it teaches us about our own priorities. It shows that our fascination must be matched with care, or else discovery becomes destruction. We learn too about our resilience in facing ignorance. Many fields of science build upon layers of knowledge, with each generation adding to the last. In the ocean, the gaps are vast. Entire groups of animals remain undescribed, entire systems remain unobserved, and yet scientists keep working. They accept the incompleteness, knowing they will never finish. That acceptance shows something about us as a species. We are willing to pursue knowledge even when final answers are impossible. We can live with fragments and still find meaning in pursuit. Searching them reflects that resilience, that ability to work without the guarantee of completion. And searching the ocean teaches us about scale. We are used to thinking in terms of human lifespans, human distances, human timescales. The ocean ignores those boundaries. It moves in centuries, in millions of square kilometers, in depths that dwarf mountains. Searching it reveals how small we are by comparison. That realization can be unsettling, but it can also be liberating. It shifts perspective, showing us that we are part of something vast. It reminds us that our knowledge is partial, our presence temporary, but our curiosity part of a larger continuum of discovery that stretches across generations. Another hidden lesson is adaptability. To study the ocean, we invent new tools, from submersibles to genetic sequences. Each failure pushes us to adapt, to think differently, to refine methods. Searching them teaches us flexibility, resilience, and creativity in problem solving. These traits are not only useful for science, they reflect broader human capacity. The ocean, by resisting us, strengthens us. It forces us to grow, to rethink, to reimagine how to learn. Perhaps the most profound lesson is that searching them teaches us humility about knowledge itself. We often imagine that with enough effort we can know everything. The ocean shows us otherwise. No matter how many expeditions we send, there will always be more unknown creatures, more hidden systems, more secrets. The unknown is not a temporary gap waiting to be filled. It is a permanent condition of life. Searching them teaches us to live with that condition, to value the pursuit without expecting completion. It teaches us that mystery is not failure, it is part of reality. And in learning this, we learn something about ourselves as explorers, as thinkers, as beings who live in mystery. We learn that we search not to conquer, but to connect. We search because mystery draws us, because the unknown sustains imagination, because discovery feels meaningful even when it is incomplete. The ocean is a mirror in that sense. Its unknown creatures reflect our desire to know, our struggle with patience, our capacity for wonder, and our responsibility toward what we touch. From here, the thought flows naturally forward. Because once we see that searching them teaches us about ourselves, the question becomes what we do with that knowledge. Do we let it change us? Do we allow the recognition of humility, responsibility, and connection to alter how we act toward the sea? These are not abstract questions. They lead directly into how we close each journey into the deep, how we carry the lessons back with us, and how we rise again toward the surface while holding on to what the unknown has taught us. There comes a moment in every journey into the deep when the dive must end. Whether it is a human inside a submersible, a remotely operated vehicle tethered to a ship, or an autonomous probe sent on a timed mission, the ocean eventually reminds us that our presence is temporary. Lights dim, batteries run low, oxygen dwindles, and the ascent begins. The transition from the pressure and darkness of the abyss back toward the surface is more than a technical maneuver. It is a movement across worlds, a slow drift from the realm of the unknown into the space of the familiar. And in that movement, reflection often begins. Those who have been in the deep describe the feeling of leaving it as a kind of reluctance. Even after hours of silence and limited visibility, there is a sense that more waits just outside the beam of the lights. The ocean feels unfinished, as though you are leaving a conversation halfway through. Every shadow could be another undiscovered animal. Every current might conceal a hidden form. As the submersible rises, the awareness grows that what has been seen is only a fragment of what exists, and that the mysteries remain behind, unchanged and untroubled by our departure. The ascent is often slow. It takes time to move upward through kilometers of water. That slowness forces reflection. Scientists review the footage or specimens they've collected, talking through what they observed, speculating about what might come from it. They know that even the best dives capture only fractions, and that analysis on land will be long and uncertain. The excitement of the dive lingers, but it is tempered by the recognition that questions have multiplied faster than answers. That is the nature of returning from the deep. You rise with more mystery than you descended with. The drift toward the surface is also a reminder of how fragile the encounters were. Many creatures seen below will never be brought up intact. Many will remain only in memory and video. The samples that do survive are often damaged, difficult to preserve, or impossible to keep alive at surface pressure. The deep holds on to its inhabitants. Our attempts to extract them into our world are partial at best. That realization sets in during the ascent. The jars and cameras carry fragments, but the living whole remains below. For those inside submersibles, there is also the physical sensation of pressure lifting. At depth, the hull creaks faintly, and every part of the vessel is under stress. As the ascent begins, that stress eases. The knowledge of safety grows, but it comes with awareness of what is being left behind. The body relaxes while the mind resists. Surface light will soon replace darkness, and with it comes the return to familiarity, noise, and speed. The patience of the deep gives way to the rush of air and waves. Even for those observing from ships above, the retrieval of vehicles carries similar tension. Hours of waiting in darkness end when the ROV or lander breaks the surface, dripping and battered. Crews gather eagerly, not just to recover equipment, but to glimpse what has been recorded. Sometimes there is disappointment, nothing unusual captured, no rare creatures observed. Other times there is exhilaration, a new species, a surprising behaviour, a fragment of life never seen before. Either way, the act of retrieval marks the shift from exploration back into interpretation, from the unknown back into the known world of analysis and debate. What makes these returns striking is that they emphasise how different the deep ocean is from the surface. On land, exploration often continues indefinitely. Scientists can remain in forest for months, track animals across seasons, revisit sites repeatedly. In the ocean, exploration is always temporary. The ascent is inevitable. The unknown refuses permanence. Every dive has an endpoint, every expedition a time limit. The creatures remain below, continuing their lives indifferent to our presence. We return upward, carrying only what little we manage to record. And yet, the ascent is not simply an end. It is also a passage. As we rise through the layers of the ocean, from the blackness of the abyss to the faint blue glow of the twilight zone, we pass through gradients that remind us of how stratified the sea is. At one depth, bioluminescence dominates, flashes of light against darkness. At another, faint outlines appear as traces of sunlight filter down. Higher still, shapes become clearer, fish and jellyfish reveal their forms, and then suddenly the surface light breaks through completely. It is a return to brightness, but also a reminder of everything that exists invisibly below. The surface itself feels transformed after time in the deep. The sky seems brighter, the air sharper, the waves louder. There is a sense of re-entry, like emerging from another planet into the one we know. The surface, once taken for granted, now feels temporary and fragile too. If the deep is harsh, the surface is precarious, dependent on invisible systems below. That awareness often lingers long after the dive ends. Those who have been to the deep carry with them not just data, but altered perception. They see the surface as connected to depths others may never visit. Back on land, the process continues. Samples are sorted, footage reviewed, data catalogued. Months, even years may pass before discoveries are confirmed. What seemed extraordinary in the moment may turn out to be a known species behaving unexpectedly. What seemed ordinary may reveal, under a microscope or through genetic sequencing, to be something entirely new. The drift back to the surface is not only physical, it is intellectual. A slow process of moving from mystery into knowledge and often back into new mystery again. For the public, the ascent is when stories reach us, footage is released, images shared, articles written. We see the rare glimpses not in the moment, but after the dive has ended. The excitement we feel is part of that upward drift, mystery carried back into the light of shared awareness. In this way, the ascent connects worlds. What was hidden in the dark is translated into something we can all witness, even if only on screens. The creatures remain in the deep, but their images rise with us. The act of closing a dive, then, is not closure at all. It is transition. The mysteries remain below, unchanged by our brief visit. We return altered, carrying fragments and reflections, aware that what we know is still incomplete. The surface is where we live, but the deep is where the unknown endures. Every dive is temporary, every ascent inevitable, but the mysteries wait patiently for the next descent, the next attempt, the next fragile tool lowered into the vastness. And perhaps that is the lasting impression of drifting back toward the surface, that the ocean does not yield itself in finality. It allows us glimpses, it allows us to learn, it allows us to feel wonder, but it never allows us to say we are finished. Each ascent is a reminder that exploration is ongoing, that the unknown is not a boundary to be crossed but a condition to be lived with. We close the dive, but the ocean remains open.